You're watching Power Nation.
Hey guys, welcome to Trucks. Well, this is the Kevin Tate's Grocery Getter. This is my personal truck. I drive it back and forth to work, I haul stuff with it, I tow with it, and it's even been to the strip a couple of times. It's a 2000 Harley-Davidson F-150, but it is not stock. Underneath the hood is an 02 Lightning drivetrain with all of the Go Fast goodies, long tube headers, and 373 rear gears. There's a custom dyno tune on it that's pulling 400 horsepower and 500 foot-pounds at the rear wheels. And at 5,150 pounds, I've surprised a couple of Mustang GTs with this thing. Needless to say, it's a fun truck to drive.
I love that truck. Now, can you imagine a drivetrain like that with that kind of horsepower and torque in a smaller, more nimble truck that can weigh anywhere between 1,500 and 2,000 pounds less? You'd have a little rocket ship on your hands, or at least a mini version of a Ford Lightning. And since Mini Lightning doesn't sound that tough, we're calling this thing Project Rolling Thunder.
Now, we were actually looking for a single cab Ford Ranger when we found our Mazda B2500, and they look almost identical until you get a little closer. For instance, look at the bedside. It's got this kind of a cool style line that we're actually getting used to. Sort of sets it apart. The doors, well, Ford Ranger. The cab, Ford Ranger. The proof's in the pudding. When you check out the VIN and the sticker, it says manufactured by Ford Motor Company in the USA. So for all intents and purposes, it's a Ranger.
Now, underneath the hood of our well-used 160,000-mile pickup is a little 2.5-liter four-cylinder. Now, it runs fine, and I'm sure it would handle commuter duty just fine. Probably get pretty good gas mileage while doing it. But it is definitely not a high-performance power plant. Now, the 5-liter V8 swap, well, it's been done more than a few times, so we're going to stay away from that. We want to go with the next generation of Ford V8s, the modular 4.6.
Let me introduce you to our little friend. Actually, not so little. This is a 4.6-liter dual overhead cam modular engine and 4R70 transmission out of a wrecked 03 Mercury Marauder. The high-performance potential of the 4-valve modular engines, well, it's proven itself over and over again. Now, this package in a stock Mercury Marauder in 2003 kicked out just over 300 horsepower in a completely stock car. So you throw some aftermarket stuff at it, throw a tune on it, well, you can start to see the potential. Now, obviously, the original engine and transmission are going away, but here's where you can take a page out of the Ford factory service manual and save yourself some time, because unlike an S10, the Ford Ranger cab, aprons, and radiator support, well, they're spot welded together. So just like we did when we pulled the engine out and swapped the Lightning engine into my Harley truck, well, we're going to take the cab off of the chassis. There's 6 bolts that hold it on and some engine connections. It comes straight up. You roll the chassis out from underneath it. Save yourself a lot of time. Plus, it's going to give us the opportunity to give you guys a closer look at what we're doing. Now, I know that right now there's guys talking back to their television saying you don't have to pull the cab to pull the engine, and you're right, you don't have to. However, the ability to do this type of work flat-footed and not laying on your back on a creeper, well, it's definitely worth the extra effort.
And since the air conditioning on our little Mazda still worked, well, that means it's full of Freon. And the air conditioning compressor is going to stay with the rest of the system and go up with the body when we separate it from the chassis, until we can deal with it the correct way. And separating the rest of the cab from the chassis, well, it was simple as pulling the bulkhead connector on the floorboard of the cab. Made it really easy.
And with the driver controls and harnesses separated, all that are left are 6 bolts holding the body to the chassis. Now, believe it or not, the cab is actually not that heavy. So even without a lift, with a few buddies, you can set the cab and nose on some jack stands. Now, Ford Service Tech will tell you that everything we've done is standard procedure, except the surfing.
Now, pulling the exhaust system was pretty straightforward, and we were able to remove most of the hardware with the help of some penetrating oil. But separating the downpipe from the exhaust manifold, well, that took a little heat.
And with a swap like this, it's kind of uncharted, so you never really know what you're going to reuse and what you're going to throw away. So we're carefully disassembling everything rather than hacking it up and throwing it in a pot.
Now, we're not really sure what we're going to do with this 4-cylinder engine and 5-speed transmission. I guess we could sell it as used parts or make a really, really fast go-kart.
Now, obviously, weight bias is pretty important with a project like this, so we're weighing everything that we pull out of this truck as well as the new components we're going to put in. The stock engine and transmission come in right at 537 pounds, which is actually a little bit lighter than we thought it was going to be. Now, with the new engine and transmission, unfortunately, we're picking up a couple hundred extra pounds, but we're also picking up a couple hundred extra horsepower, and that is a trade-off we'll take any day. From there, it becomes a balancing act and trying to effectively plant that power to the rear wheels, get this thing balanced out.
Now, Kevin and I obviously have quite the challenge ahead of us, shoehorning this gigantic dual overhead cam 4.6-liter engine into an engine bay that was designed to house a 2.5-liter 4-cylinder. Now, there's no doubt about it, it's going to be a tight fit, but we'll make it happen. Now, for stage 1, the heavy automatic transmission is going to stick around. But once we go to stage 2, we're going to swap it out in favor of a lighter manual transmission, because what we're after is the best possible power to weight ratio. We just need to make sure all the power we're making finds its way to the rear tires and onto the ground. And for that, we've got a pretty cool and unique solution.
Now, we've stripped the frame down to the bare bones, including pulling the engine mounts out of the cross member, just to give ourselves as much room as possible, because let's face it, that modular engine is just plain bigger than a typical small block Ford V8, and there is no kit for this engine swap. So it's going to be a pretty good challenge that by the end of the day, we have that giant drivetrain fitting comfortably into a compact truck.
Now, to make sure that happens, we went ahead and did a little bit of prep work. We pulled just about everything we could off the firewall, and we pulled the plastic inner fender liners to gain clearance and to help us see what we're doing. Now, check this out. We also made some relief cuts on the pinch weld at the base of the firewall and on the trans tunnel. That way we can get as much clearance as possible to help us shoehorn that giant engine and transmission combo down into the engine bay. Now, dropping this big 4.6 down in between the frame rails is actually the easiest part of this mock-up. So we're gonna have to drop the cab down, make some adjustments, and push some things around to see what we've got to work with. All right, now there's no doubt about it. It's a tight fit, but the engine's in here, and we actually have about an inch of clearance between the back of the cylinder head and the firewall. We definitely needed to remove the heater box, and the exhaust is gonna be a tight squeeze, but we got all kinds of room up here for a radiator. All right, now we've gone ahead and taken some measurements on where the engine is sitting right now, because we know it fits and we don't want it to move. But before we start building some engine mounts, we want to see if we can get this factory Mazda crossmember to line up with the Mercury Marauder transmission mount, because as it sits right now, it's pretty darn close. Now, the bolt holes look symmetrical, so we may be able to get away with dropping the crossmember, flipping it 180 degrees, and reinstalling it. And hopefully everything will line up. And even if it doesn't, well, the bolt holes for the mount itself are drilled offset of center, so we may be able to flip that around as well to see if it'll line up. We got a couple of variables to work with, so I think we can get it done. Well, I don't think that's going to work. Now, it looks like by flipping the cross member around, we've actually moved it too far forward. And the way it was before, well, it wasn't that far off. So I think what we can do is oblong the mounting holes where the cross member installs to the frame. That should give us the adjustment we need. It goes to show you, maybe try working with what you got. The solution may be cheaper and easier than you think. And it was as simple as using a cone-shaped carbide burr and our die grinder to oval the holes out. Hopefully everything will line up. Let's see if this works a little bit better.
Now, you're not going to sacrifice any strength by elongating holes, especially with 3 mounting bolts on either side. So it just goes to show you, it pays dividends to try and work with what you've got instead of whipping out the credit card.
I don't know why we didn't do that first.
The 4-valve heads have a unique port design, so we're tied to a certain style of manifold. We're going to solve this problem later and just get them out of the way for now. Yep.
All right, we're there.
Cool. Perfect. Well, with our transmission locked into place and our wood blocks holding up the oil pan, this is exactly where this engine is going to sit. Now all we have to do is fabricate some kind of a receiver for the existing engine mount.
The plan we've got for that is just to create a flat mounting surface for the engine mount to sit on. Now I went ahead and cut out a cardboard template roughly the same size as the factory engine mount. Cut a hole for the mounting stud, and once I transfer this over to 3/16 plate, cut it out and drill a hole, well, we'll go ahead and install it, tighten down the nut, and tack weld the steel plate to the cross member. And we'll pull the engine back out, burn in the welds, add a gusset or two. We should be in good shape.
Factory Marauder engine mounts are perfect for this 4.6 swap. Now, even if you didn't use a Marauder engine, you can get these over the counter or from a junkyard, and they really make it easy.
All right, drop it down. All right, slow down. Yeah, right there. All right, lift up. All right.
With the top plate located, you can use transfer paper to make your gusset for the other side. Now, we're only gusseting one side so we can have access to the stud with a fastener. After a quick double check to make sure the plates are level, Ryan burns in the gussets.
She's home.
That's cool.
Very nice.
Now, one of the coolest things about the dual overhead cam 4.6 are the giant cam covers. But unfortunately, that's also one of the things that makes it a little more difficult for an engine swap like this. But the placement that we've got a lot of room for just about everything, including room up against the firewall on this side. But the firewall on this side, well, it's adjusted out. It's kind of ballooned out here to make room for the driver controls, steering shaft, etc. So what we're going to do is flat plate this so it matches the other side. And we're going to use the piece that I cut out as our template. Tracing around your template, give yourself a 1/2 to 3/4 of an inch of extra metal. Using an electric shear, I'm rough cutting around my marking, since it's a process of cutting and trimming from this point. Now, just like selecting the correct hammer and dolly, you want to choose a forming tool that closely resembles the shape of the workpiece you're trying to create. In our case, it's a pair of duck-billed vice grips from Matco. Now, obviously, we're not trying to reskin the entire firewall. All we're after here is giving a symmetrical firewall on either side of the transmission tunnel so our giant cam cover doesn't interfere. Making some relief cuts with a hand shear allows you to easily form a curve in 20-gauge sheet metal. Once I'm happy with my rough shape, I'll start to tack it in place with rosette welds and then hammer form my way around the edge for a nice flush fit. Leveling the welds of the flap wheel is purely for cosmetic reasons, but this is a visible panel. We'll follow that by prepping with a red Scotch-Brite pad and sealing the patch. We're using Loctite black RTV sealant, but you could use an automotive seam sealer as well. The point being, you want to seal the patch so you don't have any vapor leaks or moisture leaks.
For stage 1 of this conversion, we're going to keep the automatic. But when we go to a more high-performance stage 2, we're going to swap in a manual. So rather than buying a drive shaft now and a drive shaft later when we go to stage 2, well, we're just going to try to shorten the stalker and save a few bucks.
Build on a budget. Truck projects that save you time and money.
Now we're going to need to swap over the Marauder transmission output onto our drive shaft. And we've showed you guys this stuff before, but this time we wanted to show you a couple of tools to make the job easier. Now both these tools we picked up from Matco. The first is an air hammer attachment that drives on the yoke and drives the U-joint cap down into the tool itself. It'll save you from having to do the hammer and socket method. The second is some U-joint snap ring pliers, and it'll keep you from inventing new words, getting frustrated with needle nose. That was too easy. The impact hammer and attachment makes quick work of removing the rusted-in-place U-joint caps. Now, like we said, this is going to be a temporary drive shaft until we can move on to stage 2 and buy a high RPM, fully balanced drive shaft. But there's still a couple of things we can do to make sure this job gets done as accurately as possible. Now, to make sure we don't upset the balance of the drive shaft too much, and to make sure the U-joint yokes stay in phase, we make a mark down the length of the drive shaft. We also mark the 2 inches we're going to cut out of it. After making sure the tube is level and perpendicular to the saw blade, we can go ahead and make our cuts. Now, if you're wondering why we're not making the modification closer to the yoke, well, that's where the weights are attached, and we don't want to get into that area. Plus, the larger diameter section we're working on will just increase the weld strength. Using the red scuff pad, we'll first clean the area to make sure we get a good clean weld. The second thing we'll do is put a slight bevel on the end of the tube to make sure we get good weld penetration. Now, here's another tool that's pretty handy. This is a magnetic ground clamp attachment. A few MIG tack welds will hold everything in place until we can measure for run out before the final welding. All right, with our temporary drive shaft tack welded together, we want to make sure the run out is within a reasonable amount before we fully weld it in. Now, to do that, we're going to use these aluminum V-blocks and a dial indicator. Now, scrubbing off any surface rust and applying a little bit of grease to where we're going to be spinning our drive shaft will minimize any rolling resistance, making it easier to turn, and increasing the accuracy of our measurement. Now, ideally, you don't want any run out, but a good rule of thumb is you want it less than 5 or 6 thousandths. All right, once you're happy with the run out, you can go ahead and fully weld it together. Just remember, do small sections at a time. You don't want the drive shaft to warp. Now, if you guys need to get a job like this done at home and you don't have the tools and equipment or the experience necessary to lay down a decent and safe weld, well, you can take a measurement, send your drive shaft off to a drive shaft shop, and they can shorten it and fully balance it for you, for not too much money either. And now that we got our engine and transmission locked into place, we're going to roll the chassis back under the cab one more time, set the cab down, and see how much clearance we gained with our new Firewall relief.
Now, obviously, one of the biggest challenges for any late model EFI swap is engine management and communication, but we have got that covered in a big way, but you're going to have to keep watching to see that. For now, we're going to declare this phase mission accomplished because it fits less than a ½ inch of firewall clearance, but that's okay because we have the bulk of the engine weight back behind the center point of the spindle, which is really going to help us balance the weight of this vehicle out. And now check this out as well. We've got nearly 10 inches of clearance between our front engine accessory drive and the stock radiator support. So we'll have all kinds of room for really effective cooling and an electric fan. And check this out too. The stock brake booster with a little bit of creative slotting is going to fit right where it's supposed to. Now, we needed to buy about an extra ½ inch of room to make a brake booster work with our new 4-valve super wide cam covers. We even thought about maybe going to a Hydro Boost system on this truck, since it is rack and pinion with power, and a lot of later model Mustangs live happily with that system because it's narrower. But the more we started looking and measuring, the easier this project got. Now, this is the brake and clutch pedal assembly. This is a pretty simple device. It basically sandwiches the firewall between the booster and the bracket itself. And it's bolted into the top of the cowl from the inside. Now, what we did by slotting this is effectively create our ½ inch of space so we can drag the whole assembly towards the outer apron. But slotting this is only half the story.
Now, we modified the firewall that same measurement Kevin modified the bracket, about a ½ inch, because we just didn't have a ½ inch of clearance to gain by slotting this hole outward. Plus, it would make this aluminum bracket really weak. And this area has got to be really strong. It goes through thousands and thousands of pedal cycles over the truck's lifetime. Now, for a little extra insurance, we also ground down our coil covers just to make sure this thing will fit. Now, time to see if it does. And we even got clearance for a screwdriver, about a ¼ inch all the way around. We're in good shape.
Now, on the other side of the engine, if you remember, we completely removed the entire heating and air conditioning system just to free up the space and see what would fit and what wouldn't. Well, as it turns out, about half of the heater box doesn't even fit. This half, that housed the air conditioning part of it. So we just completely eliminated it. We don't need air conditioning because we got the 260 air, which is both windows rolled down to 60 miles an hour. You know the drill. Anyway, what we had to do, cut half of the heater box off. Now we have a holder patch. Now this is an easy fix because it's not like this box is pressurized. All we have to do is block the airflow off so it redirects it back inside the cabin so we have defrost and a little bit of ventilation. This can happen with a simple patch, which starts with a template. Now usually you can transfer the template onto something like fiberglass or even another piece of plastic and just glue it in place. But we've got something way cool to show you. This is a product called Hyperfiber from Percy's High Performance. It's lightweight, strong with a twill weave, and it's easy to work with. It comes either with the wire made into it to hold the form a little bit better, or flexible without the wire. They have a resin and a filler that are both UV curable, just like the Hyperfiber. But here's the deal. It's not fiberglass. There's no resin to mix in, there's no window of time before it kicks and gets hard, and there's no risk of over-mixing because everything you need is already in here. It stays flexible, just like this, until you expose it to UV light, which is outside. You set it outside, everybody's got access to that. But if you're in a box like us with no windows, well, it's going to stay formable until you hit it with a UV light source, like this light that they also provide and sell on their website. Step one is simply trimming the Hyperfiber to fit your workpiece, and we're using the Hyperfiber resin to aid in adhesion. Once you're satisfied with the basic shape, peel one side of the plastic coating off and fit your patch to your panel. Now, unlike fiberglass, there's no hardener. You have all the time in the world to fit your piece. A little bit of tape will help you lock things in until you expose it to UV light. Now, you don't need a curing light to cure the Hyperfiber. You could just set it outside and expose it to natural sunlight. Our light is available from Percy's, but any ultraviolet light source will work. There you go, harder than a frozen hot dog. And all we got to do is clean up the edge a little bit and throw a coat of paint on it. But remember, these glasses I'm wearing, they're part of the equipment. It's not a fashion statement. They're UV protective glasses. And if you get a cure light, don't even look at it. You can damage your eyes. But you pay attention to a few basic rules. This is a wonderful new product.
All right, with a couple of our engine swap problems solved, we need to move on to the steering, because obviously the factory setup's not going to work with that giant hunk of aluminum in the way. Now, what I've done is drilled a small hole in the firewall, slid in this piece of brake tubing so we could line everything up with the base of the steering column, get everything mocked up. That way we can pull the cab off and get the steering problem solved. Now, to get the job done, we picked up a few parts from Borgeson. Now, obviously, the Ford steering shaft had a fairly straight shot down to the rack. But since we've got a pretty hard angle with the steering snaking around the exhaust manifold in the frame, well, we picked up one of these. This is a double universal joint with the Ford factory V-style attachment at one end and the standard double D input at the other. Now, since we're going to be running multiple U-joints, we also picked up a 3/4 inch rod end for some support and this cool Firewall bearing flange. Now, to connect everything, well, we're obviously going to have to run some 3/4 inch fully polished double D shaft. Now, since the universal joints are needle bearing equipped, well, it's not only going to be precise, it's going to be factory smooth. This double jointed piece really helps us get down to the original Ford steering rack in between the exhaust manifold and the frame. And this short section of double D that attaches to the longer section that goes up to the column needs to be supported with a rod end to keep it from flopping around under steering input. We used a piece of 1¼ inch DOM and a 3/4 inch grade 8 nut that we basically turned down so half of it would fit inside the tube, basically made our own tube insert. Then we added a couple of plug welds and some TIG welds all the way around the circumference. This thing should be plenty strong.
Now, just because the engine fits the hole doesn't necessarily mean that the extra wear items like air filters and oil filters are going to fit as well, especially with an engine swap. Now, fixing the steering linkage introduced us to another problem that we've got to solve, which is the oil filter. And on that particular engine, with its location, it just doesn't work for us. Sometimes you can get by with using a shorty filter like this guy, but in our case, no, it just doesn't work with the frame rail, suspension location, all that kind of stuff. So what we did is give Maximum Motorsports a call, and they sent us one of their high-end oil filter relocation kits. The filter mount and block adapter are billet aluminum and black anodized for a cool look. All the brackets and hardware are included, and a high-performance oil filter comes with the kit. Dash 10 AN fittings are also included, as well as zip ties, even some thread sealant for the threaded ends. They also throw in enough braided line to put this pretty much anywhere you want, and some spiral wrap to protect any of the soft items that the braided line may come in contact with. So with this filter relocation kit from Maximum Motorsports, we're certainly not compromising on any quality, and we don't have to build our truck around this. The kit comes with everything you need to relocate your filter and detailed instructions. Now, one of the hassles with AN fittings and braided steel lines is completely eliminated with the Cool Tools fixture, which simply mounts in the vise and you do a quarter-turn press with your braided line, instantly placing it into the AN fitting. Now, the adapter mounts on the block just like a filter with an O-ring seal. So what we're going to do is mount the lines in loosely and then figure out the location of the filter when we get the cap back on.
Now, some of you guys may have noticed the exhaust manifolds bolted to our 4.6. Well, they're not the Mercury Marauder manifolds that came on it. That's because we've ditched them in favor of some that will flow and fit a little bit better. And here's what we swapped them for. These are 03 Mustang Cobra manifolds on loan to us for stage 1. And they actually give us about a 1/4 inch of clearance between it and the control arm mounting bracket. Now, for the rest of the exhaust system, here's what we have in mind. Now, we're definitely going to be using a pair of MagnaFlow heavy metal catalytic converters in the high flow variety. But as far as mufflers go, well, it's really hard to tell how loud a truck's going to be by looking at a picture in a catalog, because we want this thing to be loud but not obnoxious. After all, it is named Project Rolling Thunder, so we ordered up a few muffler choices. Now, our first option is this 4-inch round race muffler. Now, I'm guessing that puppy's going to be pretty loud. Our next option is the 5-inch round race muffler, and the third is the more traditionally shaped 4x9 muffler. Now, all of these are stainless steel, have a flow-through design, and have 2.5-inch inlets and outlets, so we can interchange them and pick the sound we like best.
On the passenger side, it's a pretty clear shot from the manifold straight into the cat at a 45-degree angle, then back into some 2.5-inch straight pipe into the muffler and a quick 90 out the side. Now, if we were doing a symmetrical dual exhaust system, it'd be a no-brainer. But check it out. We have the fuel tanks. We physically can't do it. We got to snake around a bunch of other stuff. So obviously, the driver's side, well, it's a whole other story.
Yeah, because we've got a couple of 90-degree bends to make. One to go from the driver's side converter down the cross member, and another one to send the tubing down the frame rail to the rear of the truck to meet up with the muffler. Now, to do that, we're going to use this piece of equipment right here. Now, we know you guys probably don't have access to a tool like this, but if you send your car off to a muffler shop for a custom exhaust system installation, this is probably really similar to the piece of gear they're going to use. Now, by using the interchangeable dies, this machine's capable of bending tubing ranging from 1 3/4 inches all the way up to 3 inches. And by using a variety of fixtures, tools, and attachments, you can use the ram at the other end of the machine to do a traditional flared flange, a flat flange, or even a ball and socket type flange. Heck, you can even expand the piece of tubing you're working on for a slip fit connection, making doing custom exhaust work a piece of cake. Now, just like the hydraulic tubing bender we use for roll cages, well, this exhaust tubing bender is a piece of cake to operate. No giant manual levers here, it's all push-button control. Now, we know this non-Mandrel bent 90-degree angle isn't the ultimate in flow, but for our 300 horsepower application, the 2.5-inch tubing will help get us by, and it should be plenty for stage 1 of this build. And when putting more than one bend in a piece of tubing, we need to make sure it stays on the same plane. That's as simple as using a level. Now, to make the down pipes that connect the exhaust manifolds to the catalytic converters, well, we're simply using a TIG wire as a template. And since our factory manifolds have a flared fitting, well, that's what we need to add to the down pipes. Then they'll bolt right up. Now our driver's side exhaust tube with the S-bend actually turned out pretty nicely. And it kind of mimics the second gen Lightning's factory style exhaust system. And I'm guessing these twin 4-inch mufflers are gonna sound pretty nasty. Now for the brakes, well, we showed you earlier how we relocated the booster by sliding the bracket. We've now hooked up the master cylinder, the pedals are inside hanging where they need to be, and the coil cover, well, we had to grind it down for booster clearance. We made it look like new again with the help of some sandpaper and some Duplicolor semi-gloss black paint.
As far as the steering shaft goes, well, we know exactly what to do to connect it to the column. We just kind of ran out of time today. But the heater box, well, the Hyperfiber fix works great. We've got tons of clearance between the box and the cam cover, and now we have the ventilation that we need for defrost and for heat. The other thing you saw us do was to mount the engine part of the oil filter relocation kit that we got from Maximum Motorsports. Well, now with the cab down on the chassis, we've got the perfect spot for the filter mount. Check it out. We've got the filter tucked safely behind the front bumper for protection, up against the frame rail for further protection to where it's not going to come into contact with any road debris. But that's not all. Look at this.
Now the downpipes from the manifolds were definitely a tight fit, but our converters are snugged up in the frame rails pretty nicely. Now we'll have to do heat shields for things like brake lines and fuel lines, and we'll do that before we get the truck up and running. Now, so far, everything's just clamped in place because we don't know how loud these mufflers are going to be, and we may have to swap them around for the larger versions. Tailpipes kick out the side. Now, we've gotten quite a few engine swap details taken care of today, but there is one topic we've kind of been avoiding, and it's not everybody's favorite, but we've got a pretty slick solution for it. It's the wiring harness. We've also got a pretty clean solution for the non-return style fuel system.
So far, we've stuffed in the 4-valve Marauder engine and transmission and reinstalled our shortened drive shaft, following that with a custom bent dual exhaust system that kicks out the side just like a full-size Ford Lightning. So that gets you guys up to speed on what we've already done to the truck and kind of brings us to an area that we've sort of been avoiding the whole time, which is the challenge of wiring and starting an EFI swap like this one. Well, we got some help today. Jeff Dunn from Done Right Performance is bringing something really cool to the table. And if you remember, we used Jeff's mass air conversion on our first-gen Lightning. A mass airflow system, like the GT Mustangs have been enjoying since 1989, is more efficient and infinitely more tunable. So we're going to use this mass airflow conversion kit from Done Right Performance that includes a new ECM or engine control module, an injector harness that plugs into the module and accepts the vehicle's injector harness, allowing you to control and monitor the rest of the vehicle systems. Oh, and by the way, in case some of you Chevy guys have already forgotten, it was the Ford that actually won the Muscle Truck Series. But even though EFI is nothing new, there's still a lot of guys, including myself, that just get a little intimidated with some of the voodoo involved in wiring an EFI engine swap. So what makes your system different?
It's interesting you use the word voodoo because you're right. A lot of people see wiring one of these engines as sort of a black magic, if you will. And while we may not necessarily be able to eliminate the mystery of one of these engines, we think that we've done a pretty good job to eliminate the complexity of wiring one of these engines.
Yeah, but you're telling me that, but I'm looking at hundreds of wires, multi-pin connectors, but yet you're telling me there's only 4 wires I need to be worried about connecting to make this thing run?
Just 4. You got a battery positive, battery negative, we got a fuel pump, and a 12-volt key on.
Well, that's no more complicated than a carbureted engine.
Not with our kit.
Well, why don't you show us and everybody watching how simple this is to make this engine run?
Let's do it.
Cool. This system uses a factory-style multi-pin connector and plugs right into the existing engine harness. Don Barron, also from Done Right Performance, came down to help us fire off the Ranger. He's routing a power feed to the existing 4-cylinder fuel pump just so we have a fuel supply to start the engine. Now this is kind of a demonstration on how simple the system is to hook up. So we're using this toggle switch as our key-on voltage source, connecting the basic connections to a battery standalone, and we'll be using a remote start later on to fire the engine off.
Now with our connections made, well, we still need a computer to make our 4-valve 4.6 run. So Jeff also provided us with a 99 Cobra production PCM with a chip installed that disables the passive anti-theft system. And they also hooked us up with an 80mm Pro M mass airflow sensor and high flow conical filter. Now, the Done Right system is designed to work with the more popular 99 to 04 4-valve Cobra engines. And while our Marauder 4-valve is largely similar, there are some subtle differences, with the intake facing the opposite direction, putting the throttle position sensor and a few other items on the wrong side. So to make the Marauder harness work with the Done Right system, well, they offer this adapter harness that plugs in between the two. Now, if we decide to go to a Cobra engine when we convert to stage 2, we simply remove this adapter harness, plug everything back together, we'll be up and running.
Now, Jeff likes to tell us that with his Done Right performance system, we could get this engine to run in a shopping cart. Well, as you can see, we're about as close to a shopping cart as we could be with the engine sitting in the bare chassis. But like any other internal combustion engine, we got to have a fuel source. Now, our truck came with a returnless system with the fuel pressure regulated in the tank. Now, technically speaking, our truck came from the factory with a mechanical returnless system. Now, you Cobra guys, well, you know that you've got a returnless system, but it requires a fuel pump driver module to make this system work. Since we have the option from Done Right Performance, we decided to go return style just to simplify the system. So we had to change a few things around. Our temporary fuel supply line comes from the in-tank pump into a filter and then up to the fuel rail. The fuel comes back from the fuel rail into a temporary return line back into the tank, recirculating the fuel, creating a traditional return style system. Now, if you're keeping up with this, you're probably wondering how we're going to connect a fuel return line to a fuel rail that's designed to be returnless. Well, Jeff's got us covered with that, with a pretty cool solution that's going to save you time and money.
So the first thing we want to do here is we're going to remove the original fuel rail pressure sensor. This is the sensor that feeds information to the original Marauder PCM so that it could determine proper voltage to the fuel pump for correct fuel rail pressure and injector pulse width. Now, our return line conversion starts with this adapter block. Just make sure the O-rings are lubed before installing. The fuel outlet gets a new gasket, and the fuel pressure regulator's O-rings also get lubed. Now, to get the fuel back to the tank, we're using a -6 90-degree fitting sealed with Teflon tape. And lastly, the vacuum reference hose is installed under the fuel pressure regulator.
Now, since we don't know the overall condition or how many miles are on the original Mercury Marauder spark plugs, we're going to go ahead and replace them with a fresh set of these E3 Diamond Fire plugs.
Now, it's pretty safe to assume that the stock fuel pump is not going to supply the demands of a big V8 engine. This was made for an inline 4-cylinder. So what we did was went to O'Reilly Auto Parts and got a Mercury Marauder fuel pump and just put it in line. We also clipped the return line so it wouldn't get internally regulated, but just flow freely into the tank. So now we know our fuel pump is going to match the demands of the engine, because that's what it's made for. Speaking of fuel, we know the fuel in the tank is decent. We put it there and we drove around on it. But we don't know about the fuel in the fuel rails of that engine. It could have been sitting for years. So we're going to use some Start Your Engines, which is designed to stabilize fuel and bring vehicles out of storage. So it should do a good job on those injectors. Now, even without a filter relocation kit, it's a good idea to fill the filter up before you install it. But remember this, do not get any contamination into the fill hole. It's a direct connection to your engine and will get pumped directly into the oil passages and could damage your bearings. Now, we're reusing the Mercury Marauder inlet tube, but we've loaded it with the Pro-Am air meter and filter that come with the kit. The rest of the connections are just as simple. They're one-way plugs that you can't make a mistake on.
All right, with that stuff taken care of, we're just about ready to fire this thing off. And like we showed you earlier, it only takes 4 wires to get it up and running. But you may notice we got a couple of extra wires here because we're going to need some more communication with the body once it's dropped down on the frame. Now, one of these wires is an AC compressor on signal, the other being a tach feed, capable of running a traditional analog tachometer. Now, this toggle switch is acting like our key on signal, with this being our start switch.
Check that. That is awesome. Well, there it is, man. It's as easy as you said it was. 4 wires and we're up and running. Jeff, Don, thank you guys so much for your help. Wow, this is incredible.
Well, and if you decide you want to go with the supercharged Cobra motor, you're all set with that as well.
Cool deal. Well, you guys just get the truck back together and up and running. We're going to go check email, and we'll check in with you when you're done.
I'm going to stay here and listen to this thing run.
Now, here's a couple of the things that you haven't seen us do. We actually bought a V8 Explorer radiator, but the core size was identical to the original 4-cylinder radiator, so we sent it back, saved some money, and we're repurposing this one. Now, obviously, we've lost the mechanical fan from the 4-cylinder with the 4.6, so we went to Summit Racing and purchased this 17-inch puller that should be pretty good and pretty efficient. On the radiator hoses, again, we went to the parts store and pieced some stuff together that is going to complete the cooling cycle. The upper hose is a stock one, so again, we save money there. And we're kind of betting that between the efficiency of the cooling fan, all the space we've got between the fan and the engine, as well as, believe it or not, there's still some pretty good room underneath the hood, despite this being a compact truck. So all told, this should be pretty efficient in the cooling department.
Now, based on the discoloration of the stainless steel exhaust tubing and catalytic converters, it's pretty apparent we've been running our 4.6 in the shop quite a bit. Now, before we run it anymore, and certainly before we drop the body back down on this thing, we got to do something to isolate the heat that the exhaust tubing and cats make from any non-metal object, like the wiring harness, sensors and switches on the transmission, as well as the transmission shifter cable. Now, catalytic converters can operate in a heat range of 1,200 to 1,600 degrees. That's why the OEMs take so much care to insulate the areas around them. And with ours sitting right next to the transmission and the transmission cooler lines, well, we don't want to heat up the transmission fluid any more than we have to. So to get that done, we're going to use a combination of simple aluminum heat shields and some exhaust heat insulation products. Now, installing the exhaust wrap is pretty straightforward, but you are going to need some stainless steel zip ties or retaining straps to hold it in place. Now, to hold the heat shields in place, just using a couple of self-tapping screws. Now, the thermal protective wrap we put over the exhaust tubing and secured with stainless steel zip ties came from Taylor. And they also make this thermal protective sleeve that's good for up to 1,200 degrees Fahrenheit. So we're going to put a section of this over top of our plastic-coated B&M shift cable. The last thing we need is that outer plastic layer melting. Now, we know our shifter cable was built to withstand some heat, but our 4.6 is going to make plenty of it. So we're installing this just to be on the safe side. All right, with our heat issue resolved, we can move on to one of the last pieces of our little stage 1 puzzle here, and that's getting the automatic transmission operational. And when this engine and transmission combo sat down in between the frame rails of the 03 Marauder that it came out of, well, they were both electronically controlled by the same computer, the PCM, or powertrain control module. And since we've got our dual overhead cam 4.6 running on a standalone engine management system, we need to do something similar for the transmission as well, since it's also electronically controlled. So we picked up a standalone harness and a standalone computer for it as well. Now, the wiring harness plugs directly into a few key sensors on the side of the transmission. Now, it also allows you to wire in a neutral safety switch right into your start circuit. Now, the other end of the harness, one piece plugs right into the computer, and you've got a handful of other connections to make for throttle position sensor, RPM input, a couple of power and ground hookups, along with a couple of other connections. And with the Illuminator transmission control system, you can even set your truck up to have 2 separate transmission files or calibrations. Say you want to set it up to have normal, everyday street driving characteristics, and you want to be able to flip a switch and go to a more aggressive shift pattern to match your more aggressive driving, well, you can do that. Or say you got a street strip vehicle that's maybe spraying nitrous, and you want to be able to load a more aggressive or race type transmission calibration when you activate the nitrous, well, you can set it up for that as well. Or you can do like we're going to do, keep it really simple and run a single tune. But there are a couple of changes we need to make to the software before we load it up. Now the Illuminator software comes preloaded with a few different calibrations. We've chosen a 4-valve Cobra file because it'll pretty closely match what we want out of our Ranger. The problem is the Cobra has about a 500 RPM red line advantage over our Marauder engine. So we're just going to go in here, lower the shift points across the board so they're just underneath our 6100 RPM red line, save our progress, we can upload this file into our computer. And it's so easy, even I can do it. All right, once we get this wiring harness installed, power and ground hooked up, and everything plugged in and connected to the computer, we can upload the file from the laptop. We should be up and running. Now, installation is really straightforward, with the harness utilizing factory-style connectors plugging right into the Ford sensors on the transmission.
From the first moment we hit the road, rolling thunders sounded and felt really strong. And as fun as it was driving the ultimate sleeper, the stock suspension kind of started to show us some problems that we already knew we had. But horsepower wasn't one of them, unlike when we first got the truck. Now there's all this truck can handle, and then some.
And after putting a few miles on the truck, we noticed a less than healthy noise coming from under the hood.
Yeah, that rattle, you can hear it more at very light throttle, almost just off idle, than you can under load.
Heard it then.
Yeah. I think our screaming deal engine wasn't so much of a screaming deal.
Now, we knew we had a slightly wounded engine, but it was really tough to resist the temptation of our newfound 300 horsepower. And just cruising around, we didn't have any engine noise whatsoever. And the gauges looked great. Heck, even our stock 4-cylinder radiator kept our V8 nice and cool all day long, never getting above 200 degrees with the help of the electric fan.
But the engine noise was still there, and we knew we were pushing our luck. So we reluctantly headed back to the shop. Yeah. Wow, that is definitely what we're hearing inside the cab. And if I was a betting man, I'd say that's a connecting rod getting ready to let go. But you know, that's okay, because we got a screaming deal on this engine. The guy that sold it to us was a salvage yard, and he even said it was from a theft recovery vehicle. So even if we did have to spend the coin to rebuild this, we'd still be all right in it. But you know, the real reason to stick this engine in here was to make sure that it fit and get this truck ready for the next step.
Yeah, and with that accomplished and the engine a little bit injured, well, I guess we have no choice but to move right into stage 2, which we've been anxious to do anyway, so no big deal. Now, we definitely got some drivetrain upgrades we're gonna make, along with some unique suspension modifications that are a little bit outside of the box. Now, as far as the original Marauder engine's concerned, well, we'll yank it out, set it off in the corner and let it collect dust, or maybe ship it off to Horsepower, see what they can do with it. Either way, we've got some serious hardware to replace that thing. And at least we got to put a few miles on this truck. Let's get it inside.
Man, it looks good under there, doesn't it?
Yeah, I hope the new one fits too. We've been chomping at the bit to get right to stage 2. And, well, there's no better time than right now.
But before we started tearing this truck apart, again, we wanted to throw it on the scales and see what our weight bias was, front to rear, as well as how much weight we've actually added by swapping to a V8.
And it looks like we've got some pretty good news as far as overall weight and weight bias is concerned, especially considering that our V8 and automatic combination weighed 200 pounds more than the anemic 4-cylinder 5-speed combo that came in our little Mazda Ranger. Now, originally, our truck weighed in at 3,090 pounds, but the scales show us we're now weighing in at 3,125, meaning we only picked up 35 pounds overall. And even better yet, well, our weight bias is still at 62%. And that tells us all the effort we put into setting the engine back as far as possible, doing a slight relief to the firewall, and all the other little things we did to either remove weight altogether or locate that weight farther to the back of the truck has paid off. And it's got us on the right track to getting closer to that ideal 50-50 weight split front to rear for stage 2 of this build.
Now, you heard Ryan right. We've switched to a V8, a 200-pound heavier V8, but our vehicle weight is still almost the same. Where'd that 165 pounds go? Check this out. The rubber mat, liners, exhaust system, the condenser, the AC system, all of this stuff seriously contributes to a lot of weight loss. And we haven't even gotten serious about weight reduction yet. But there's another great way that we can reduce weight and increase efficiency, and that is by switching from an automatic transmission to a manual.
Yeah, because with the convenience of an automatic comes a weight penalty. Not to mention, they're just not as efficient at transferring power as a manual gearbox. That's why we're going with this Tremec Magnum T56. Now, this is a new 6-speed transmission from Tremec, and there's lots of cool stuff to talk about, but we'll get to the details later. For now, I will tell you, this thing will handle 700 foot-pounds of torque, which makes it a perfect match for our engine. Now, to connect it to the engine, we're using this lightweight steel SFI certified bell housing from QuickTime. Now, due to its compact design, it maximizes header and transmission tunnel clearance. Now, a lot of guys just reach for an aluminum bell housing, but we're going to be making a lot of power. We're not going to be easy on the truck. So to play it safe, we went this route. Speaking of lots of power, check this out. Now, just like our Marauder engine, this bad boy is a 4.6-liter dual overhead cam V8 out of the Ford racing catalog. You guys might know it better as the Illuminator. Now, it's based off of the legendary and nearly bulletproof 03 and 04 Mustang Cobra Terminator engines that were capable of producing and withstanding gobs and gobs of power. Now, one of the things that makes this one different and where it got its name is this one has an aluminum block, saving us some weight. Now, the Illuminator comes in two different versions, a high and low compression, either 10-to-1 or 8.5-to-1. We went with the low compression because we're going to be running forced induction and lots of it. Now, one of the best parts about this engine, it's got brand new rod bearings.
Now, you Cobra guys know that the stock Terminators came with the Eaton M112 root-style supercharger. Not a bad piece of gear, but this is an awesome upgrade. This is the Whipple Ford Racing 2.3 root-style supercharger. Now, just bolting this on a stock Terminator is going to get you an additional 85 horsepower at the wheels. Now, one of the cool things about the Whipple is that the front pulley is interchangeable. With this 3.5-inch pulley, it's going to get us somewhere around 13 pounds of boost. But the good thing is, if you want to make more boost, it's as simple as reducing the pulley size.
With this swapped-in engine clattering and making not-so-healthy noises, it was time to go. And Kevin and I have both been anxious to ditch the slush box automatic in favor of a manual transmission. Now, the engine we're going to be installing in place of the wounded Mercury Marauder 4.6 is going to be a little bit heavier due to the blower and intercooler and supporting hardware. So to counter that, we're going to be installing a fuel tank at the very back of the frame instead of the mid-frame mounted stock plastic tank. So we just sent some dimensions to the guys at Rick's Hot Rod Shop, and they crafted up this super slick stainless steel tank. Now, we're going to drop it right in between the frame rails and behind the rear axle. And that'll help us with the weight bias. But before we do that, we got to figure out the rear suspension.
Now, we wanted to do a little bit better than just some lowering blocks or shackles and really enhance the handling capabilities of this project. And there's lots of aftermarket options out there. There's 4-links, there's Watts links, there's all kinds of torque arm systems that are really well engineered. But we wanted to go independent rear suspension. Now, since we're completely redesigning the front suspension and doing a custom one-off setup, we wanted to go with more of a subframe system for the rear, and we found a killer option. This is an IRS from a Cobra Mustang. Ford introduced these in the Cobras in '99, but this one is from an 04 with the beefed-up 31 spline half shafts, limited slip differential, and 373 gears. Now, there's good and bad points about this IRS system. The good point is that it's designed to handle the power output of a supercharged engine application, which is precisely what we're going to be throwing at it. Bad points? Well, there's a wheel hop issue. You Cobra guys know this. And it's due to the rubber isolators and the various design aspects of the IRS. Now, because of that, a lot of straight line guys ditched this entire system in exchange for a stick axle, which also makes this inexpensive and available. Not to mention, there's aftermarket support to compensate for the factory shortcomings. So the bottom line is this is an adjustable, strong, independent suspension system that is going to up the ante and really turn our little truck into a corner carver.
Now, another reason this stock fuel tank has got to go away is that it's going to try to occupy the same space as that IRS subframe assembly Kevin just showed you. And needless to say, the 7.5-inch rear axle has got to go as well. And I'm kind of surprised that this thing held together under V8 power during the test drive. But I guess the fact that the engine was a little bit wounded and these bike tires weren't exactly hooking up helped the axle live. Now we're stripping the front suspension down just for the sake of getting it to a bare frame. That way we can set the frame at ride height and work the front and rear suspensions separately. Now there aren't any off-the-shelf bolt-in kits whose primary focus is to get the truck to handle better. They're mainly designed to sit the truck lower down for looks and aesthetics. But I guess that's to be expected since nobody really takes a pickup truck to a road course. So we're going to be on our own for a completely custom front suspension that handles. Well, we've got the frame of Project Rolling Thunder just about completely stripped down in preparation for some pretty serious suspension modifications. But before we cut off the first bracket or even make the first weld, we wanted to point something out. Check this out. With the front of the frame on jack stands on both sides, we've got a good 2 or 3 inches of flex underneath this left rear corner. So we're definitely going to have to address the torsional rigidity issue. And all that movement is without any weight in the chassis, which is only going to amplify the problem. Now, to remedy it, we've got a couple of things we're going to do. We're going to add some bracing, and we're going to weld some of these cross members that are currently just riveted in place, like this one that's holding the front and rear frame sections together by way of the leaf spring hanger, which is going to go away. So it'll get all welded together, and that'll help stiffen things up. But the biggest thing we can do to increase the overall chassis stiffness is to install a well-thought-out roll cage. Now, it's hard to tune a suspension or even calculate spring rates when the frame itself is acting like a spring. But before we break out any tools, we want to drop the body down on the frame, select our ride height.
Well, check out the new mocked-up stance of Rolling Thunder, and it is amazing how much difference lowering a vehicle and throwing a set of wheels and tires on can do for the appearance. But as good as this thing looks, appearance is not our main goal. We want to make this truck handle. Now, the wheels and tires are something that we borrowed from a horsepower project out in the warehouse, but they're similar in style and size to what we're eventually going to be putting on this truck. Check this out as well. See the negative camber we've dialed into the mock-up of the wheels and where they sit. It's going to give us the ability to really make this truck handle, having adjustability on all 4 corners. Not to mention the fact that some negative camber on the back end of a pickup truck, well, it's not something you see every day.
And take a closer look at the front wheel well. We've marked the fender and dropped a plumb line where the original front axle center line was. And we've shifted the wheel forward 1.5 inches because that's where the new front axle center line is going to be, lengthening the wheelbase. And that's going to have the same effect as moving the heavy engine and transmission rearward in the chassis, helping with that weight distribution we've been stressing so much. And only because it's going to make this truck handle the twisties. And with this giant wheel well, if we hadn't have told you, well, you probably wouldn't have noticed. Now, one of the things that's going to help us move some of the weight to the back of our pickup truck is by relocating the battery. Rusty's off-road battery box is laser cut from 1/8-inch stainless steel, meaning you never have to worry about corrosion issues, making it great even for marine applications. It's got 8 mounting holes on the bottom, and only 2 bolts hold the lid in place, making it really convenient. And it'll hold any Optima battery out there. And for a show car look, all you got to do is polish the stainless. Now, we're obviously getting away from the budget a little bit, because that was stage 1 of this project. And we're going to spend a little bit more coin this time around. But we're going to try to do it wisely.
Now, part of that sinister plan is to take tried and proven high-performance racing parts and fundamental techniques and apply them to this chassis, such as the independent rear suspension that we borrowed from the 04 Cobra. Now, another place that we drew some inspiration is from another track-prepped V8 Ford Ranger that was featured on Power Block not too long ago. This 95 Ranger belongs to Matt Beauchard of Beauchard Racing and Fabrication, and it's a little bit of inspiration for us in our project. The functional splitter and full-on roll cage make this a 100% race truck, powered by a 302 carbureted V8. Custom front and rear suspension of Matt's own design make this truck handle like crazy.
Now, just like you guys, we don't have a frame jig or a frame table to work off of. So we're going to use a flat and level section of our concrete shop floor to get the job done. Now, the last time we had our truck in the shop, we took the body, set it down on the bare frame, and selected our ride height. And we just welded on these stands, which is nothing more than a piece of tubing, a nut and a washer welded to it, and then a bolt on the bottom so it's threaded and height adjustable. That way we can level out the frame and make sure everything's right. Now, the first step in installing our IRS subframe is going to be to remove all the shock mounts, leaf spring hangers, and brackets that are going to be in the way. That way we've got some clean and flat real estate to work off of. Now, our favorite way of removing the stubborn factory frame rivets is to cut an X in the head and use a sharp chisel on our air hammer. Makes quick work of it. All right, we've got the rear spring hangers and shock mounts knocked loose from the frame. But before we remove this front spring hanger, we want to make sure this is tack welded together and nice and solid. If you take a closer look, you can see this front frame half and rear frame half overlap and are attached at this point by this cross member and about 6 or 7 rivets. 4 of them holding this hanger in place. So just to be extra cautious and make sure nothing moves around, we're going to weld this up and make it solid.
And we wanted to compare the weight of our Cobra IRS suspension system with the stick axle and springs that we took out of the Ranger, just to show you the difference. Now, our Cobra system, minus brakes, weighs in right at 309 pounds. In order to get an accurate representation of what this thing weighed, with brakes, springs, all that kind of stuff, well, we're just going to actually stick it on the scale. That brings us to, wow, 367 pounds total weight. Now, with the entire independent rear suspension completely disassembled, Ryan's going to grab the subframe and get started on the installation. Now, the biggest mechanical advantage to an independent rear suspension is that when one wheel moves, it doesn't affect the other wheel. Unlike with a stick axle, when one wheel travels up, the other one has no choice but to react and to move kind of along with that. So an IRS has a handling advantage right off the bat, but it gets better because it's tunable. And just like a front suspension, there's an upper and lower control arm, with the upper having an adjustable eccentric, which allows you to change the camber setting or the tilt in of the wheel and tire at the top. Now, another tuning point on this system is the adjustable tie rod, which gives you a toe-in adjustment and helps you really control the way a vehicle tracks with this system on it. Now, the Cobra systems like this have a slightly larger sway bar than the GT, along with the beefier 31-spline CV half shafts and, of course, the giant lower control arm that's cast aluminum. Now, as good as this system is, the aftermarket allows us to make it even better. I've left this side completely assembled to show you where we can improve it. Now, the spindle, or upright, has a spherical style upper and lower ball joint, and they're not worn out and fairly precise, so they're going to stay. But the upper and lower control arm bushings, well, they're made out of rubber, and although they offer a nice, smooth, and vibration-free ride, they're going away. Now, the control arm bushings are different sizes, so match up your removal tool to the bushing with a test fit, and follow that by the spacer, washer, and nut, and snug it up by hand. Then, using hand tools, slowly tighten the nut and the assembly. It's important not to use pneumatic tools so you don't force any distortion into the aluminum control arm. Now, it may take a while, but you're going to know when the bushing comes out. Now, aluminum control arms are lightweight, but aluminum is soft. That's why they provide a scuffing pad, so you get rid of the schmutz and the corrosion, and you don't distort the aluminum. It's very important that you have a nice, flush fit with the new Delrin bushings. Now, don't confuse Delrin with urethane. It's a much higher durometer and does not compress. Delrin was actually invented in the 50s by DuPont and is used as a bearing in Hot Wheels. Pretty cool. Now, this is going to work great for us for a test fit. And by the way, don't forget some anti-seize on the bolt threads and in between the washers to make sure everything doesn't bind. Now, the shims and the lube, that happens on final assembly. The shims really are only there to take up any slack that may have been created by eliminating the rubber bushing. So for now, this is going to serve us very well, and I've got a few more of these things to do.
All right, with the subframe blown apart and the frame ground down to bare metal in a couple of spots, well, we can finally get to the installation of this thing. Now, we knew where to locate it and how to position it based off of measurements that we took and from information we gathered from the helpful and knowledgeable tech guys at Maximum. Now, before we disassembled the stock truck, we measured where the rear axle center line was of the leaf-sprung solid axle pickup, and that's right here. Then we also determined the axle center line of the independent rear suspension system and matched things up. Now, the first thing we're going to do is install and weld in some temporary bracing to lock the subframe in place. Then we can get to work making up and fabricating some mounts to permanently mount the subframe. But it's still going to be bolt-in and it's still going to be removable. Now, after measuring and measuring again and triple checking and measuring again, we determined we had the subframe sitting at the exact ride height and location that we needed. So we just locked it in place using some 1-inch angle iron. And these will serve as temporary braces until we can design and cut out some permanent brackets using our Torchmate. Now, like we told you earlier, this thing's gotta be removable. So it took a little extra time to make brackets that would bolt into the frame. But it's gonna be time well spent if we've ever gotta work on any of these suspension parts that require a little extra clearance. So let me show you what I've done. Now, the first thing I did was plasma cut a couple of holes in the backside of the tubular subframe. And that will allow us to install this plate with 2 1/2-inch grade 8 captured nuts welded to the backside of it. Once that's welded solid, we can install our cross member, which is a piece of 1 3/4 DOM tubing that we bent up on our hydraulic tubing bender, along with some 3/16 plate we cut out using our Torchmate. And once everything's welded solid, we can install the cross member on the inside of the frame rails and weld it up for good. Now, if you notice the location of the cross member mounting points, well, they're right here above the lower control arm pickup points. And that's because that's where a lot of the suspension energy and load is going to be transferred. So doing it right here will eliminate any subframe deflection, often found in the factory IRS setup. The front half we did a little bit differently. This is a piece of 1.5-inch DOM welded directly to the subframe and then again to the bottom side of this bracket. And that'll handle any vertical loads. Any side-to-side movement will be handled by this piece of 1-inch 3/16 Walt DOM, again welded to the same bracket. We've got a couple of captured nuts welded to the inside of the frame rail, a gusset for strength, and this thing is removable and still plenty strong. But we're not done yet. Now, just to make sure this subframe is installed as rigidly as possible, I went ahead and added another piece of plate in between the upper control arm mounting points. This top piece will become the bracket that's welded to the frame rail. But before we do that, we've got to notch the frame for upper control arm clearance. Once we do that, we'll box in the remaining section of the frame rail and add the necessary gussets. Now, the benefits of having these brackets at the frame or even inboard of the frame is that it allows us to remove the goofy, flex-prone factory subframe end. Now, this thing was designed to fit an existing Mustang platform, and now that we don't need it, we get to cut them off. Now, the things that limit running really wide tires and wheels on the back of a Mustang are both the shock and the forward subframe mounting point. So by eliminating these, we give ourselves more options for fat rubber.
Now, I wanted to show you what the rest of the components in the Maximum Motorsports grip pack look like, as well as what a little bit of elbow grease and paint can do for the appearance of this stuff. Now, these stock sway bar end links are going away to be replaced by the Maximum links, which are billet aluminum and hind jointed for adjustability of sway bar preload. The stock CV half shafts, well, there's nothing wrong with them, but we media blasted them and threw a coat of paint on. They're good to go. The upper control arms have the Delrin bushings set into place. We also media blasted and threw a coat of paint on them. They look pretty good. Now, the lowers, we blasted them as well, but we didn't paint them. Instead of painting, we put a barrier coat called shark hide that's supposed to keep it from oxidizing and keep the appearance of aluminum pieces and other raw metals looking good. We're going to test it out and see how it works. Now, the 8.8 pumpkin just got cleaned up, but the rear isolator, which is rubber, gets replaced by a solid billet aluminum piece, just as the front left and right isolators are replaced by, again, solid but adjustable billet pieces. Now, the last pieces of this puzzle are the stock tie rod ends, which get replaced by these lightweight, hard anodized billet aluminum rods, again, with heim joint ends that are bump steer adjustable. Now, all of these pieces will virtually eliminate any wheel hop issues that we may have had with the stock system, and look pretty snazzy doing it.
Now, everything's assembled and loosely bolted together, and everything fits just like it's supposed to. And it looks pretty good, too. But let's take a closer look at what we did for upper A-arm clearance and what we did to finish off the upper subframe mounts. Now, once we were happy with the amount of frame we trimmed for A-arm clearance, we went ahead and plated the bottom of the rail and boxed in the remainder. Then we just added these vertical gussets for our upper subframe mounts. Then to finish things off, we added this top plate for strength and to help out in the looks department. And we'll obviously box in the frame rails from this point forward. Now, if you're doing a project, anything similar to this at home and you're worried about compromising on strength, well, there's no need to. Think about this. The factory IRS subframe assembly was held in place with just 4 bolts. Here, we've got 12 of them. So those 12 bolts, along with the cross members, brackets, and bracing that we've added, I'm sure we've significantly increased the stiffness of the subframe itself and this entire frame section, which is a good thing, because this truck is going to get hammered on.
Now, it doesn't make any sense to do all these chassis upgrades along with a supercharged high horsepower engine and not pay attention to the brakes, because trust me, we want this thing to stop. So out back, we're using EBC's dimpled and vented Cobra rotors. Now, we're using a bit of strategy here because we've picked up an extra set of rotors, and they're red stuff and more aggressive yellow stuff pads. So once we bed in the pads to a specific rotor, well, they become a match set, so we can easily switch depending on where we're driving from a street to a track setup.
Now, for our application, we knew we were going to need a better than stock replacement clutch. So we went to Summit Racing and picked up some parts from Centerforce. Now, the disc itself is a dual friction unit with a segmented carbon composite lining that'll keep heat down while increasing torque capacity. And the pressure plate features aircraft-grade billet aluminum and a heat-treated and replaceable friction surface. It also features their patented ball bearing activated diaphragm and standard Centerforce centrifugal weight system. That'll increase clamping load as RPM increases while still maintaining reasonable pedal pressure. Now, the aluminum flywheel we picked up is from Centerforce as well. It's got a mechanically retained starter ring, and just like the pressure plate, it's SFI certified and has the heat-treated and replaceable friction surface. Now, these parts are designed for specific road racing applications along with drag racing. And while they do cost a little bit more, well, they definitely have benefits. The engine's going to rev faster, it's easier to match revs while shifting, and the engine's just going to plain old accelerate faster due to the lower inertia. But before we install it, we've got some measurements to take. The first thing we're doing is installing the bearing assembly and making sure it's sitting flush. Then we can take our first measurement from the bell housing mating surface to the front of the throwout bearing. But before we can get our second measurement, there's some installation work we've got to do, like getting this pilot bearing installed in the back of the crankshaft. We're using an impact socket and a mallet. Next was the bell housing's separator plate. We followed that with the aluminum flywheel. And since this thing's going on for good, we use some red Loctite on the bolts to make sure it stays put. And after starting the bolts by hand, we're just snugging them down using the impact wrench. We follow that with an accurate torque. And by using an alignment tool, we can finish up the job getting the clutch disc and the new pressure plate installed. Now, the first step in tightening down our pressure plate bolts was to torque them to 33 foot-pounds. But these are torque to yield factory bolts, so we need to go an additional 60 degrees. But what if you don't have a torque angle gauge? Well, you can do like we're going to do and just use a template. Now, you can use a piece of cardboard or whatever you got laying around, but we had this old steering wheel kicking around and we're going to use it. Basically, we just marked off 60 degrees on the outside edge of the wheel. We'll line our ratchet handle up with the first hash mark and tighten till we hit the second mark. That way we know we've gone 60 degrees and it's done right. Now, once you get started in this process, you need to make sure that the crankshaft and the flywheel don't move. If it moves on you while you're turning the ratchet, you'll lose track of where you are and have to start all over again. Now, to make sure it stays put, Kevin's using a flywheel holding tool we picked up from Matco. And with the bell housing installed, we can get that second measurement we needed. And it goes from the bell housing to transmission mating surface to the very top point of the clutch fingers. And using these measurements and doing a little bit of math, we were able to properly set the height of the adjusting sleeve on the throwout bearing. It needs to have an 1/8 inch clearance in between the face of the throwout bearing and the clutch fingers to operate properly. Now for our application, we ended up using the provided spacer sleeve. Now the 2 O-rings on the throwout bearing are a snug fit, so if you need to, lubricate them with brake fluid only. One final measurement will verify we're still right on the money.
That's it. Cool.
And last but not least, we can install the bell housing, hopefully for the last time.
Well, Project Rolling Thunder is going to be one seriously fast little street truck with a rock-solid foundation that handles like a slot car. Part of creating that foundation involves boxing the frame all the way back. Now, boxing a chassis in is nothing new. There's really nothing new under the sun. This has been done for years, and it's quite a simple process. It involves using cardboard for templating, tracing out your design, transferring it to metal, and then trimming it out and welding it in place. It's pretty simple and can be done with basic tools, so this is a project you guys can do at home. Now, we're going to box all the way back, leave a little bit of room for suspension travel, and go all the way out the back. And since our new fuel cell is going to sit right here where the spare tire carrier now sits, obviously this boat anchor's got to go away before we can box these rails in. Now, weight transfer rearward is one of our main overall goals for this project. So we're going to have to buy back some of the weight that we're losing by removing this spare tire well. But the stainless steel fuel cell that we're installing in its place will more than compensate, especially when it's full. Now, cutting off the factory rivets is kind of fun, and it satisfies some weird primal urge. It's kind of like therapy. Now, templating is a simple process of tracing and trimming. And you want to start off cutting a little bit more than the outside edges of your project, and then dialing it back in, which is much easier to do on cardboard than it is steel. A little more forgiving, too, if you make a mistake. Now, the second most used tool in the whole shop is a black marker, and it's used to trace the pattern onto the 1/8 inch plate steel. Now, we're using our Torchmate CNC plasma table to cut the speed holes. We just found something round and the right size laying around in the shop to use as a template. So all of our boxing plates are cut out and trimmed, and the speed holes are cut out, and we're ready to tack these things in place. Wanted to show you something first. This is not just for aesthetics, although they do look cool. Check this out. These are the cutouts for about half of the boxing plates for one frame rail. And it's weighing in at 8 pounds. So you got 16 pounds worth of weight just from cutting the speed holes without sacrificing strength. If that doesn't sound like much, think about this. Got the rear bumper, the spare tire well, all the different brackets that we're pulling off. The point is, all of this matters. We get the strength that we want, and we get the weight reduction that we want, because every little bit helps. Well, the frame's a little rusty, but nothing a couple passes with the grinding wheel won't fix. Then we're ready to tack our plates in. Now, we're tacking all of the plates in individually, just in case we have some fine-tuning or trimming to do. A tack's a heck of a lot easier to cut out than a fully burned-in weld. Now, the factory-formed rails are not square or symmetrical, so you may have to do some forming. With everything looking good, you can make some fire.
Well, we've got most of our boxing plates welded in place, and we're grinding down those welds for a little bit more finished look. Now, we've got some more plates to make and some more welding to do on both the cross members and the bottom side of the frame rails. But we're going to take a break from this for a second because we want to drop our new engine and transmission down in between the frame rails and see where our transmission mount lines up.
Now, the good news is we know the engine's going to fit, because essentially it's exactly the same engine block, and we're using the same isolators or engine mounts that we use on stage 1 with the Mercury Marauder engine. The problem here is that these are factory and they're rubber, and the aftermarket doesn't really support a Mercury Marauder mount. They have Cobra mounts, so we're going to have to switch to a Cobra mount later on. We'll cross that bridge when we come to it. The important thing is knowing where this transmission mount's going to go and what we're going to have to fabricate to make this work. The other variable are these long tube headers. Mike and Joe over at Horsepower had these Flowtech long tubes kicking around, so we just thought we'd throw them on, see if they fit down between the rails, or if we're going to be locked into the factory Cobra cast iron manifolds that we know work.
And to make sure the transmission ends up in the right spot, we're installing our original Marauder engine mounts. Oh, yeah, that figures. Well, just like we suspected, these Flowtech long tubes are not going to work unless we do major surgery to the headers themselves or to the frame rails. So we'll probably end up going back with the manifolds we were running, which may not be that big of a deal. The Cobra manifolds are known to support major horsepower numbers, so I think we'll be okay. Good on my side. Good?
Yep.
All right, from the camera point of view, it may look like the mount's gonna line up with the cross member. But from where I'm sitting, we're a good 2 to 3 inches from having the holes line up, which is no big deal. We wanted to ditch this factory stamped cross member and replace it with a tubular one. And that way, we can keep it tucked up in between the frame rails and keep it from hanging down too low, because ground clearance is gonna be pretty important with our new and much lower ride height. And we've discovered one more thing as well. There's a difference between the Marauder oil pan and the Ford Racing Illuminator pan, giving us a few more inches of clearance, allowing us to drop the engine down, lowering the all-important center of gravity. But there are plenty of other things to consider before we start making modifications to get that done. We've got to think about steering rack placement, exhaust clearance, and firewall and hood clearance for our now blower-equipped V8 engine. So we've got to drop the body back down before we get into all of that. But one thing we do know for sure, these factory suspension mounts or pickup points, they're going away. Now the upper control arm mounts came off pretty easily, but the lowers were a bear. They're about 1/4 inch thick and they're double layered. And it gives you an indication of how much more stress the lower arms are under in comparison to the uppers. Ford didn't want these things going anywhere. Now the upper control arms are rod end equipped and adjustable so we can dial the suspension in. They utilize screw-in Chrysler ball joints. We attach them to these ball joint adapters we picked up from Whitby Motor Cars, and they allow us to bolt the upper arms to the SN95 Mustang spindle. Now, the tubular lower arms are from Factory 5 Racing and feature greasable polyurethane bushings and a built-in coilover mount. Now, by using the Mustang spindle, well, it gives us access to commonly available and reasonably affordable big brake kits. As far as this nasty hub goes, well, we're going to get a new one on there. This is just for mock-up.
And with our frame all boxed in, it really moves this project forward and allows us to do things like mount our custom fuel tank. This tank came from Rick's Hot Rod Shops, the Rick's Tank Division, and it's a custom-made stainless steel fuel cell that was made based on the measurements that we emailed to those guys. They also sent us some 90-degree bends. That way we can mount this thing at the location and height that we choose. Now, one of the best features of this fuel cell is the fact that it's internally baffled. And since we're going to beat on this thing on several road courses, this is going to take care of any fuel slosh issues that we may have and keep us from starving the fuel system. Now, speaking of fuel delivery, take a look at this. This is our new dual fuel pump setup that's made by 4 Precision Works. Now, this is a great upgrade for the 03 and 04 Supercharged Cobras, which makes it the perfect pump system for the arrangement that we've got here. It features 2 255 LPH pumps and is fully billet aluminum. And since 4 Precision gives us the option, we opted for a return-style system with a -8 fuel delivery and a -6 return line. And this ought to make sure we're going to feed that hungry monster. This rendering was inspired by an actual vehicle that Ford's SVT team put together using an 01 Ford Ranger and a Ford Lightning drivetrain. Now, this truck looks downright mean, and with the power that we've got sitting in the corner waiting to go in it, it's going to back it up, too.
Now, one thing we're definitely not going to change, because it's the same as the Ford Ranger, is this lightweight aluminum hood. Now, the rest of the swap is pretty straightforward. And since these fenders have a few dings, dents, and pop knots, well, it would take a little bit of labor to get them ready for paint anyway. So a sheet metal swap makes even more sense. Now, this would be a great project for you guys to do at home if you've got a Mazda and you want to turn it into the more popular and to some better looking Ford Ranger.
Now, we could always do a salvage yard swap. There's plenty of Ford Rangers in the junkyards, but we may end up in the same position as with our Mazda fenders and a little bit of body work to do. So we went online to LMC Truck's website, went through their catalogs, picked out some parts, and here's what we got. We started out with brand new sheet metal Ford Ranger fenders. And the one thing that's distinctly Mazda is the header panel and grille. So we got a Ford Ranger header panel that will support everything else. Now check these out. There's lots of headlight options in their catalogs. These resemble our rendering almost to a T and will give us nice bright refraction, and they're kind of cool looking. They've got several options with the grille. You can have a painted grille or a chrome grille. Again, the painted grille resembles our rendering, so we're going to roll with that, although chrome's an option for you guys. Now, the valance panel has optional fog light ducts. What we're going to do is utilize those as brake cooling ducts, since this is going to be a road racer. So the rest of it, just part swapping. Now, it doesn't take much to tear down the nose of one of these trucks. Just a few simple tools will get the job done. But keep this in mind. This truck's old enough so that some of the plastic parts and fasteners, well, they can get a little brittle. So take care taking it apart. Trust me, get a hardware box. You'll thank me later. Now, all the parts and pieces, well, they're very lightweight. And it might seem like these trucks aren't made of much, but just because the sheet metal's light doesn't mean the underlying structure is not. It's made to absorb impact on a collision, and it's quite strong. There's some obvious differences between a replacement fender and the original fender. The biggest one that you see is the fact that the E-coat, or the electrodeposition primer, is black instead of the grayish-green color. And your eyes are drawn right to this sticker. This just signifies that this fender, or this panel, has been certified by the Department of Transportation as being a safe replacement. Now, this greenish-gray E-coat is what the factory put on. So if this is still the color underneath your truck's skin, well, chances are it hadn't been crashed out. Here's what we're doing now. We're going to transfer this clip. Now, there's an easy way to release these J-clips. Just grab a hold of the spring steel tab, just lift it straight up. That allows you to replace it, and it still stays in place. It won't drop off on the floor, and it's still movable, so you can adjust this panel. Now, you can clearly see the difference between the Mazda fender and the Ford Ranger fender, at least when it comes to styling. But the mounting locations are exactly the same on both pieces. We had no trouble at all lining up the panel gaps, and the stampings were precise. Now, you want to make sure that there's no interference between the door and the new fender. This fender passed that test pretty good, too.
Looks good width-wise. For the most part, looks pretty good.
Now, making sure your fenders are properly aligned is the foundation for the rest of the truck fitting well. If the fenders don't fit, none of this other stuff is going to line up, and you're going to be chasing problems around in a circle. So fit your panels from the back to the front, you should be in good shape. Now, some of the parts come with hardware and clips. Some of it you got to repurpose from the old parts that you've taken off. We reused the mounting hardware for the headlights and marker lights from the old ones, such as these spring steel headlight mounting clips. They go in from the back side and hold the headlights in, but they can be accessed from the top. Sometimes it takes some specialty tools, so thanks, Matco. All right. Now, we're using brand new retainers to hold the grill in from the top, but we transferred the spring steel clips for the bottom from the other header and grill. Ranger. Now with the Mazda front bumper stripped down, guess what? It perfectly matches the profile of the Ford Ranger grille. And that's just proof that there's some crossbreeding going on, and this truly was a Ranger to start with. Now, the lower valance here, like we said, we want to utilize these fog light ports as some kind of brake cooling duct.
Now, it doesn't bolt right up. We're going to have to do some work to it to get it to work. But we wanted to build a chin spoiler or a splitter anyway. So we've got fabrication work ahead of us no matter what we do. Well, now that we've got 95% of the boxing done to the frame rails of our Ranger, well, we wanted to take a few minutes and show you what adding about 10 pounds worth of 1/8-inch plate steel can do to the overall stiffness of the chassis. Because if you remember last time, this frame was way too flexible for the use we have intended for this truck, with a good 2.5 inches of flex on the frame before any of the other frame points lifted off the jack stand. And now we've got that number down to about 3/8 of an inch. And that's before we add in the roll cage. And it's without the rear bumper and spare tire carrier holding the rear frame rails together. And with the stiff chassis not doing much flexing or twisting, our coil springs on the suspension will be able to do their job much more effectively. It's quite the drastic comparison when you stack them up side by side. Now what we've done here is assemble our front suspension. We've got upper and lower control arms, our ball joint adapters, and we went ahead and attached them to the spindle. Then we just welded this jig to our sacrificial hub at a height that mimics the center of the front wheel. And by placing the jig parallel to the front axle center line, setting the frame at ride height, and picking out our front axle width, we can come in here and determine if we're going to have any interference issues with the front control arm mounts. And any fine-tuning that needs to take place can be done utilizing our adjustable suspension.
Well, with the solid plan on our suspension well underway, we wanted to talk to you a little bit about the engine swap that we're doing. Now, there's no doubt that there's great aftermarket support for these 4.6 modular engines, in particular from Ford Racing with our 4-valve Illuminator engine here. But you got to keep this in mind. These manufacturers are doing these projects and these products as upgrades, and they're assuming that you either have a core or a complete donor, and that you're going to upgrade using their parts, and that they may not have every single thing that you need to do the swap in their catalog. Now, this upper idler pulley bridge and this AC delete pulley, well, they are from Ford Racing. I'd suggest that you go to Ford Racing's website, search their catalog, see what they do have, but there's some things that we know they don't. Now, you might just be surprised as to how many of these parts are still available at your Ford parts counter. The engines are new enough and popular enough to where they may have replacement parts in stock, or they can find them through their distributors. The issue is that sometimes over the parts counter, the dealership can get a little bit spendy. So you can do what we did. Surf a bunch of Ford performance-specific forums like StangNet, like SVT Performance and Modular Fords, and find a guy, just like we did, that's swapping from his root-style supercharger to a turbo system. And he's got all his swap parts available, like the charge cooler, the lower intake, coolant manifold, the IC coolant pump, which is, by the way, the same for the Lightning, so you can find one on a Lightning forum as well. All the duct work and coolant routing, including the lower cage pulley. My point is this: you're going to have to do some digging and hunting around and swap meeting to find all of this stuff, but hey, that's kind of fun anyways. And once you do have all of the pieces that are going to make up your Terminator and all the accessories, then the aftermarket kicks in. You can turn the wick up. Now, you can pick up a stock Eaton supercharger for a Terminator all day long. Fairly reasonable. And that's because most of the serious Cobra guys are upgrading to this bad boy. Now, this is the Whipple 2.3, which incidentally is available from the Ford Racing catalog. They give you a choice of an upper pulley, and for a throttle body, we decided to go with this AccuFab single blade throttle body, which gives you 70% more airflow, almost 1,700 CFM of airflow. Now, this setup is capable of nearly 20 pounds of boost, so to keep up with those extra atmospheres, you got to give it enough fuel. We're using 4 Precision Works beautiful billet fuel rails, their fuel pressure regulator, and their fuel pump hat that we showed you earlier. Now, since we're beefing everything else up, we certainly didn't want to compromise on the transmission. Now, we wanted a 6-speed, but a stock T56, well, is rated at 450 foot-pounds of torque. This Magnum T56 rated at 700 foot-pounds of torque. Now, there's typical Tremec options, like the choice between a mechanical and electric speedometer sender, but the coolest thing are the multiple shift locations. You can have one on the transmission body and this reversible on the transmission tail shaft housing, giving you 3 different shift locations and lots of different options. Now, the Magnum T56 is essentially an aftermarket version of the TR6060, which is the same transmission found in Shelby GT500 Mustangs, Super Sport Camaros, Cadillac CTS-V, SRT8 Challengers, and Z06 and Z71 Corvettes. So if it's tough enough for those high-performance platforms, it's going to do just fine in our little Ranger.
Now, there's no 2 ways about it. Designing a completely custom suspension system that works well is a challenge, and that's an understatement. In fact, these control arm mounts that you're looking at, well, that's version 2.0. The first edition worked great on the computer and in theory, but when it came time to applying it to our pickup truck frame, well, it just didn't work out so well. The steering rack was hitting the cross member, the oil filter, you name it. It just flat out wasn't going to work. So what we ended up doing was putting the steering rack where it would work and designing the rest of the control arm pickup points around it. Now, the lower control arm mounts are made out of 1/4-inch thick steel and welded solidly to the frame. The lower arms are from Factory 5 Racing and fit a Mustang. The upper mounts have 2 holes for adjustability. They're made out of 3/16 plate and attach the circle track upper A-arms. Now, we had to ditch our stock Ranger rack and pinion. When we built our custom front suspension, we built it to match the increased track width of our independent rear suspension out of an 04 Mustang Cobra. So bottom line, the Ranger rack just wasn't wide enough. So we picked up a steering rack from a late model Mustang to suit our needs. Now, our steering rack bushings came from Maximum Motorsports, and they're solid anodized aluminum. They offer multiple mounting positions, so we can try to dial out any bump steer, or we can move the rack slightly if we've got any slight clearance issues. Now, since they're solid bushings, well, we're going to get all the feedback that the road's going to give us, but that's a good thing on a performance truck like this. And the trade-off for a little bit of extra noise and vibration is well worth it. For tie rod ends, we're going to try to get away with using these Mustang ends. But if need be, we can upgrade to an adjustable rod end later. Now, when we were planning the front suspension, one of our goals was to minimize bump steer. Now, in case you're not too familiar with what bump steer is, here's a brief explanation. It's what happens when the suspension and steering linkages move in different arcs. When that happens, when the suspension compresses, it can actually induce unwanted steering into the front wheels. Not what you want. Now, this is more suspension travel than our truck will ever see, but it clearly shows a change in steering without any input from the driver. Now, what we're going to do to minimize bump steer on our truck is to make sure that the pivot points of the inner and outer tie rod ends line up with the pivot points of the lower control arm, both at the frame and out at the spindle. Now, if we can't get the steering linkage and control arms to move in a parallel arc by adjusting the rack bushings, well, we'll just pick up a bump steer kit for the outer tie rod end. And that way we can change the height of the pivot point of the tie rod and get our pickup truck to handle as predictably as possible.
Well, now with the front suspension done, we can lower the engine and transmission into our relocated mounts and get this thing a little closer to a more complete rolling chassis. Now, the front suspension system is a mixture of aftermarket and original equipment components, like these front seal bearing hubs that are spec'd for an SN95 Mustang. Now, they're easy to replace and inexpensive, and also support aftermarket brake upgrades, like these Brembo 13-inch rotors with 4-piston calipers that we got out of the Ford Racing catalog. Because at the end of every straightaway is a curve or a retaining wall that we frankly do not want to come into contact with. And the last piece of the drivetrain puzzle is the drive shaft. Now, a great way to reduce weight and parasitic drag at the same time is with an aluminum drive shaft. So we called Denny's Drive Shaft Service and had him make us up this one. It's his 1350 series high-speed balanced 4-inch aluminum shaft and features Spicer 1350 series U-joints and this forged Spicer slip yoke. Now, we told Denny we were going to be pushing about 600 horsepower out of the back of this transmission, and we needed a shaft that would handle it. Well, he built us one that would take double that punishment. So it doesn't matter what you're building or what you're building it for. Go to Denny's Drive Shaft's website. He's got all the forms and all the information that you need to submit an order for a drive shaft that can handle anything you can throw at it. Hey, welcome back. Well, you guys knew that we had a Rick's fuel cell that we were going to put behind the rear axle. We didn't know exactly where until we mounted the IRS cradle. Now that that's done, Ryan has done a nice job of installing some captured nuts on the inside of the frame rail, so we've got a way to lock it down. Now, Rick's also sent us some 90-degree angle brackets, so we've TIG welded to the sides of the fuel tank. That way, we can locate this thing exactly where we want it. Now, we also told the team at Rick's that we wanted the filler neck centered in the gas tank. That way, we can route it up through the bed floor and use a flush-mounted filler cap. We're also going to take advantage of the vacant real estate in front of the IRS cradle by mounting our battery and our coolant reservoir for the supercharger back here. Now, battery, typical hot rod stuff, we get it out from under the engine compartment and closer to the rear axle to help with weight distribution. The coolant reservoir is going to help us in a couple of different ways. Number one, it's going to be a larger capacity than the factory unit, and with the distance between the tank and the supercharger, we get better heat dissipation, better cooling, cooler running temperatures, more power. We made some calculations to show you guys what kind of difference you can make just by rearranging some of these components. The fuel tank itself weighs 54 pounds. 16 gallons of fuel at 6 pounds per gallon weighs an extra 96 pounds. This gives us an extra 150 pounds behind the rear axle. Now, our battery is going to weigh 45 pounds. Our coolant reservoir is about 20 pounds, and we picked up an extra 100 pounds just with the IRS cradle. That gives us a redistributed 315 pounds over and behind the rear axle. Now, you combine that with what Ryan's doing with the front end, lowering the roll center, stretching the wheelbase, well, that's getting us closer and closer to that 50-50 weight distribution we're dreaming about. Now, we want to create some protection for the fuel tank, just in case somebody runs into the back of this truck on the street, or in case sometime on the track it swaps ends and heads for a barrier. So we're going to build a protective cage around the fuel cell.
Now, this protective hoop is just 1 3/4 120 wall DOM that we bent up using our JD squared bender. Now, we designed it to sit rearward of the tank and lower than the tank. That way, like Kevin said, it'll protect the back and the bottom. After all, we don't want to scar up all the nice stainless steel. This truck is going to sit pretty low. And after mocking things up on the frame rail, we cut it loose so we can do the final welding on the floor. Then, after cleaning up the frame rails for a good clean weld, we tacked it in place again. Then we removed the fuel tank so we could get this little project finished up. Watch your fingers.
Perfect.
A Lakewood drive shaft safety loop is another part we're eventually going to be installing. And if you're doing some racing, well, it may even be required by the sanctioning body. It's a universal fit, will fit a variety of different cross members or frame rails, and with it being made out of thick 1/4-inch steel, well, it's more than capable of containing the drive shaft in the unlikely event of a U-joint or drive shaft failure. The last thing you want is some 5-foot drive shaft finding its way up through the floorboard unexpectedly. Now, it's no secret that all pickup trucks are extremely weight biased towards the front of the vehicle. So, to alleviate that problem, we had two choices. We could move the engine and transmission back into the cab, do some major firewall surgery, or we could move the front suspension forward, essentially having the same effect. And that's the route we took. And while it did help with weight balance, well, it also created another problem. And that problem is the front tire is going to want to occupy the same real estate as the fender. And it looks like we're going to have to come in here and trim some of this inner structure as well. Not only that, we're going to have this vast expanse behind the front wheel. But in the long run, it'll all be worth it and pay off big time. And even better yet, well, it's not my problem.
That's right, the problem's mine. And by the outward appearance, it looks like a big one. Because the inner structure is no big deal. We can trim it out, we can even tub it like the mini truck guys do. But the outside, not so much. We've got a little bit of space here and nothing here. If we were going in a straight line and never ever steering, maybe not such a problem, but this truck is going to go autocrosses, it's going to go twisties and windies. We need to have lock-to-lock clearance on the tires, obviously. Now, what we can do is actually a very simple solution. And since this is a single-walled sheet metal panel, it's going to be quite easy to do. Just hang in there and we'll show you. The other thing is, these LMC panels are nice quality stamping and they're relatively inexpensive at just under $100 a piece. So what we're going to do is show you how to sacrifice an additional fender, move your wheel arch forward, do a nice butt weld, metal finish it, and by outward appearances, you're never going to know the difference. With the gap set and the fender locked into place, we can start the trimming process, which begins with the wheel arch, since it's flared out and we actually need a flat surface to work against. Now with the second fender on a bench top, I can start trimming for the patch. Now keep in mind, I'm trimming way past my actual cut line. Now the reasons for this are going to be clear in about a minute, but trust me, you want to cut past where you actually want to slice and section your fender in. On the door gap, I'm cutting 1/4 of an inch in. This gives me a flat part of the panel that I can butt weld against the other fender. The inner fender brace is also trimmed so it doesn't interfere. Now here's where it becomes crystal clear exactly what we're doing. We're taking a page out of the old school altered wheelbase drag car book and literally moving the wheel arch forward to match the new location of the wheel center line. Now right now at this step, it's not an exact science, so you want to trim a little at a time. Once you're happy with the overall look and feel of the new wheel arch location, well, here's where I mark the spots and then I can double check with a plumb line later. My masking tape is going to hold the fender in place while I measure. If you got an extra set of hands, well, you can use a buddy. Ryan's hiding right now. My plumb line shows me the exact axle center line, and this way I can literally measure the wheel arch and center up the fender. I'm also using the upper style line as a guide, and once I'm happy with the location, I'm using self-drilling Phillips head screws we got from Industrial Depot to lock my new wheel arch into place. And with it screwed into place, I can literally step back and double check the proportion, because even though the measuring tape said it's centered, it still has to look right. We're working on our altered wheelbase Ford Ranger, but it's not an altered wheelbase in the traditional sense. Ours is for weight transfer, but it's a different type, since Ryan has moved the axle center line forward 5 inches to literally cheat the engine weight back and get a better balance with the truck. So my job was to move the fenders and match that wheelbase. So we're using 2 fenders to make 1. And sacrificing both of them, moving the wheel arch forward 5 inches to match the axle center line. So we're almost ready to start cutting and trimming for our final fit so we can weld it up. But check this out. You'll notice that the style line valley on this upper fender is slightly lower than the one on the bottom fender. That's not a mistake, it's intentional. Here's why. the width of my blade is going to come into play. It's 40 thousandths, and when I make my cut across the top through both panels, some metal's going away, at least 40 thousandths of an inch. And when I draw my panels together for a nice butt weld, a flush fit, well, these style lines are then going to match. So it's compensating for the width of the blade. And that way, I get a nice perimeter fit with very little gap that I don't have to fill up with a bunch of weld. Now for this procedure, I'm cutting both panels with a single cut. And I'm starting from the inside, which does a couple of things for me. It shows me exactly where I need to make my cut from the outside and not overcut. And it also gives me a precise cut of both panels. Now I'm marking my cut lines on the outside with blue fine line tape and doing a reinforcement trace with a silver ink pen. This way, if the tape goes away, I still have a cut line. Now we've sped the video up for obvious time reasons, but trust me, I'm not forcing the blade, and you don't want to either. Let the blade find a natural progression on its own. That way you're not going to distort the metal or prematurely wear your blades out. Now here's where you remove fender number 2 and carefully set it aside. Then you can take the skin of fender number 1 and say goodbye forever. Now you can test fit your new wheel arch. Once you're happy with the fit, you can clean up the outside. But notice I'm not trimming too much of the E-coat off. This can help you with sighting and your bodywork later on. Now magnets and clamps hold things in place while I get rough tacks set down and lock everything into its final position. But I'm not going to finish weld things just yet. Okay, with our section fender mounted securely on the Matco Superstand, there's a couple of things I wanted to show you before I continue with the welding process. Remember the line that I drew in the valley of this body style line, where the insert panel was obviously lower than the original fender that we're using as our basis. Now, since I compensated for the width of the blade, now these lines match up perfectly, so a little bit of forethought goes a long way with a project like this. Now here's the beauty of cutting both panels with one blade at the same time. Look at my fit. It's literally perfect. It's almost impossible to make a mistake cutting like this, and it sets it up for a perfect union of both pieces of single wall sheet metal. And if you had cut them independently and constantly trimmed, sooner or later you're going to ruin your fit and ruin both panels. Now all we have to battle is heat. Now the process of tacking and finish welding starts, but you'll notice I'm not welding very far or very much before I come in with the hammer and dolly. This gives you the opportunity to put your metal back where it wants to be and eliminate the heat damage that you've created with the tack welds. You can keep control over your sheet metal by stopping and starting and sighting. It's also where leaving your E-coat, or as much of it as possible, in place helps, because even though it's not shiny like paint, it still has a bit of a gloss, and you can literally read the surface and tell where your distortion is. Now with sheet metal, you want to stagger your welds as much as possible, jump around and keep the space between them, until you finally have a continuous weld made up of your individual tacks, and then you can proceed to flush fitting or grinding the welds flat. Now, I'm using a 24 grit disc on an angle grinder, and even with the video sped up, you can see what a light touch I'm using, because you can generate almost as much heat with a grinder as you can with a welder, so be careful. Our fender is finally ready for a skim coat of filler, and then primer, and finally paint. And as you can see, the proportion doesn't look goofy, and it fits with our stretched wheelbase perfectly. But there's still one more sheet metal project we're going to do today. And that is putting a roll pan on the back of Rolling Thunder. Now this is a steel roll pan, and it came from LMC Truck, and it ships with all the hardware it takes to bolt it in place. Or you can weld it in, finish the welds out for a nice cool custom look. I'll give you one guess as to what we're going to do. The stamped holes in the roll pan are the perfect place to tack it to the bed. Grinding the surface of the paint off is going to give me a good solid weld, and the Duplicolor weld through primer gives me some corrosion protection. The panel clamps hold things in place until I can weld, and then I can install the tailgate and double check my fit. Super. Thank you. With the top of the roll pan held in place, now we can fit against the bed sides. And like any used vehicle, this one's had a couple of prior repairs. The passenger side, well, we could just tack that into place and fit it in later. But the driver's side, well, you can see the filler we uncovered and there's an excessive gap. So we're going to use another old school custom trick and use a piece of TIG rod. Back in the day, they literally used coat hangers to fill in these gaps, but it's the same principle. You're basically using a filler metal and tacking it into your sheet metal to fill up the gap instead of cheating and using plastic filler. This is a process, again, of controlling your heat, so make sure you take your time between tacks and let your weld pool cool down. Now what I'm doing right now might seem like breaking my own rules, but here's why I can get away with it. The roll pan itself is a heavy gauge sheet metal. The bedside is a corner. Both panels are curved. Now all of those three things together give you a lot of strength, even with single wall sheet metal. So you can pour a little more heat to it and stack up your welds like I'm doing here without a lot of distortion. And with the gap finally filled, you can grind your welds flush, and it gets you ready for a skim coat of body filler. Now on the other side, we had a lot better gap with a much smaller space, so I can keep my welds a lot smaller. This, of course, minimizes any distortion and allows you to control your weld much better. Now after the welding's done, just like on the Fender project, I'm using a 24 grit grinding disc. Now that's a very, very aggressive tooth for grinding, but it actually helps to keep the metal cool because it removes much more material with a lot less effort. A fiber wheel cleans the weld contamination up, and we're ready for filler.
Ta-da! Now we've been pushing this truck around the shop on a mismatched set of wheels just to keep it mobile and allow us to move it around. But now we're ready for the real set of tires and wheels. We picked up these beautiful forged 18 by 10 inch 3-piece wheels from True Forged. Now the hoops themselves are rotary forged and fired, and the center section is bolt-in, and it's cut from a solid chunk of forged billet. Now this is their formula style. We went with polished spokes and a polished lip. But their online wheel editor has hundreds of choices. You can choose the style, trim finish, sizes, and offset. Now as far as rubber goes, these are 295 3518 BFG KDWs. And this is actually a pretty wide tire. In fact, it's just slightly narrower than the 305 35 that's on the mock-up wheel. But as wide as this tire is, well, it's for the front. That's because we got some serious rubber for the back end of this truck. I'm talking Corvette and Viper territory here. These 335 30 18s are wrapped around an 18 by 11.5 inch wheel. Now they've got a great looking directional tread pattern, good soft tread compound, and enough voids and siping to provide decent traction in the wet and great traction in the dry. These things ought to do great out on the street. Not to mention, they're gonna leave some pretty nasty looking wide stripes on the road when we dump the clutch in this truck at 5,000 RPM.
Now that is one wicked stance. So you can go to trueforgedwheels.com and design your own 2- or 3-piece fully custom wheels, or check out their new line of cast wheels for even more options. For us, now we got to design some kind of custom front air dam with a splitter, since this piece of machinery is definitely going to see some track time. Love this stuff.
Now, the big pieces are there. The engine, transmission, drive shaft, rear suspension, the brakes are on, and it's rolling on a nice set of tires and wheels. So now it's down to some of the little things. Oh, kind of like adding the engine wiring harness, bolting this big boy supercharger down, adding some ignition coils, the front end accessory drive parts, as well as running fuel lines and battery cables. And that is part of what we're going to do today.
We've also been busy on the body. Now you've seen us do the Ranger conversion on the front end of the Mazda B2500. You've also seen us do the altered wheelbase trick with the 2 sets of fenders to accommodate the 5-inch forward movement of the axle center point. And you haven't seen the wide body trick that we're doing on the bed to accommodate that giant rear wheel and tire combo. But here's something that we're going to show you today. This right here is the factory mirror. It sits right there in the door. Nothing really wrong with it, but it just looks a little pedestrian. So we want a little more high performance feel. This is a mirror base plate made out of 20 gauge sheet metal. We're gonna show you how to make this today.
But first, we're gonna get started running the fuel lines. Now we're gonna secure them to the IRS subframe using a clamp and a hole that we've drilled and tapped. And to protect the lines going into the frame rail, we're using our split vacuum hose trick that we used before. And we gotta keep in mind, we've got to add a fuel filter to this fuel system, but we'll hide that in the frame rail later. And to protect the lines from getting full of metal shavings, rust, and debris, we've taped the end shut. Now to provide an out location for our fuel line, we're just using a small hole saw and a carbide burr to create a hole coming out of the frame rail near the engine bay. We'll make sure it's free of any sharp edges later. Now you guys probably noticed we went with something a little bit different when we chose our fuel line. This is the Pro Classic hose from Russell Performance. It's got a few advantages over the stainless steel braided line that's almost become an industry standard in high performance applications. Now this Pro Classic hose, well, it's a braided nylon cover over top of a liner that's capable of withstanding up to 350 PSI. And it's impervious to oil, water, and antifreeze, making this stuff the perfect application for almost any plumbing situation on your vehicle. Now with the stainless line, to cut it, you've got to wrap it in tape first. You get loose steel ends that want to poke you in the finger, and the fittings can be difficult to assemble, especially if you don't have the special tools. Now the Pro Classic hose, well, it's much more flexible. It's lighter than the steel stuff, and the fittings can be hand assembled. Now to get electricity from our relocated Optima battery up to the front of the truck, we're going to be using a product that we showed you not too long ago. This is Excel's lightning cable. It's basically copper-coated aluminum strands, making this battery cable much lighter than standard battery cables. Notice a theme here? We're after high performance, and the lighter the truck, the better. Now the cable alone is nice, but it's not going to get the job done. So you obviously need battery terminals, and these screw-on types are the ones we like to use. Now they're great on their own, but we also like to add heat shrink tubing. It helps solidify the connection, and it just gives a nice, professional, and clean appearance. Now for a little extra insurance, we're adding some braided cover over top of the insulation on the battery cable. That'll prevent any sharp edges from cutting through the insulation to the conductive wire and shorting out the battery. Now the loop we've added that goes up around the shifter handle, well, that's just there to gauge how much length we need because we're going to be running a battery cutoff switch inside the cab. And that's just a safety precaution because this truck is going to see some track time. Now with the supercharger in place, we're running into an issue that stresses the importance of mock-up. While mock-up does kind of seem like you're just doing things twice and wasting time, well, it usually saves time in the long run. And that's essentially what we're doing today. Both these fuel hoses and the battery cable will come back out of the frame rails so the frame can be painted. We just want to make sure everything's looking good and about the right length. Now, both the fuel hoses and the battery cables were cut long. That way we can trim them to fit once we determine their exact length. Now, the issue we're running into with the fuel rails may apply to some of you guys that run these overhead cam Ford engines and aftermarket fuel rails. The threaded end on the fuel rail is really close to the metal coolant passage, especially once you add the necessary adapter. Now, even with just enough room to get a fitting in here, well, we'd still have to come up with a flex line to get over top of the supercharger or underneath it to the passenger side fuel rail. And, well, there's not a whole lot of room for a fitting there either. Not to mention, any other tubes running across the top of the supercharger just wouldn't look very good. So we've got a pretty slick solution that's going to eliminate the need for a fuel crossover tube going from one fuel rail to the other. Simply come in here with this aluminum fitting that we picked up from Russell and use it to plug each end of the front of the fuel rails. Then we'll take our fuel pressure regulator and install it in line, but prior to the rails. We'll come out of one side of the regulator into a Y fitting and feed each rail individually. Now I know you're probably saying, isn't the fuel pressure regulator supposed to go after the fuel rails? And you're right, that's the way it has been done for years and years. But a lot of fuel systems are coming from the factory with the fuel pressure regulator part of the filter assembly or even attached to the pump and in the tank. So if it's good enough for the new 5.0 Mustang, it's good enough for our 4.6.
Well, we're going to do a very cool project, hand-forming sheet metal. And it might look complicated, but it's not. Trust me. What we're going to start with is our original equipment mirror. Like we showed you, we want to get sexier, put the carbon fiber mirrors on, and these guys have to go away. But this can still be used as a pattern. What we're going to do is form a buck. form the sheet metal around it, and then trim to fit the door. It starts out with a sheet of 3/8 inch MDF. And we're going to make a 3-piece buck to give us versatility. What we do here is you've got a left, a right, and a center for support. We need the depth because the contours of the door dictate that we have to have that thickness. So this gives us the ability to make both sides off of one buck. It starts with the centerpiece as a pattern. Obviously, that fits the mirror base. This fits in the inside of our door and gives us a place to start. MDF, or medium density fiberboard, is cheap, and it's also easy to form. I didn't use a router to make this piece, just a grinder. You want to make sure you have plenty of edge to work with, so I'm marking my workpiece and marking about 3/4 to an inch around the actual buck. That way, I've got lots of room for fitment. Using my Woodward Fab tools, I'm just cutting and trimming the edges off. You could do this with hand shears. You want to make sure that your workpiece is locked to the sheet metal in one place. So I'm using some screws with pre-drilled holes to lock it in place. Then you can start forming metal, which starts with some relief cuts to make sure that the corners bend. A little bit of pressure with the hammer shows you where your buck sits, and then you can start to work your angles. Now your metal will tell you when it's tired of moving and when it's time for more relief cuts. This is a process that when you pay attention, the tone of the metal tells you things, the resistance of the metal tells you things, even the feel of your hammer tells you when to progress or when you need to make more relief cuts and conform the metal to the shape that you want. Depending on what you're working on, you're gonna know when your basic shape has been achieved, and then you can release the steel from the buck. Now with the wooden buck out of the way, you can really start to refine your project, which starts with welding the relief cuts and making it one solid piece of steel again. That way you can form against the welds and use the tension of the metal to your advantage. Now I'm using a spoon here to hammer against and give me a little bit tighter gap. I'm using my Miller-Matic 140 with a 25,000 diameter wire, which gives me a small heat affected zone. The masking tape just gives me a nice straight guide when I'm removing the excess metal. That's followed by some more relief cuts because we're going to roll the front edge over and make it look like a factory stamped piece, which is done again with a spoon and a sheet metal hammer, slowly with even pressure and an eye on what you're doing. And you can see that the mirror base is nearly done. However, the finished piece compared, we still have a little bit more trimming and tweaking to do, but we can do that up against the vehicle. The point is, with a simple buck, a few simple hand tools, a little bit of perseverance, and asking your metal nicely to do what you want it to do, you can get there from here and you can make cool projects on your own. We've got a mirror base plate bolted to the door and the APR carbon fiber mirror screwed in and bolted to the mirror faceplate. Here's how we attached it. Simple, just like the project. We used some 1/4-20 bolts from the industrial depot bin, tack welded them to the back side in the same configuration as the original plastic mirror. From the outside, you can't tell they're there, so you've got all the freedom in the world for placement of your mirror to where you can see the best. From the inside, well, it's a factory attachment. Now here's why we wanted to stay with the Mazda bedsides instead of going full-on Ranger conversion like we did on the nose. Mazda engineered this bulge into the side of the bed, so we worked off of that, sliced it, added another inch on the outside, removed all the bracing, rolled the edge back, added another 2 inches of tire clearance on these bed sides. Now, we sacrificed rigidity along here. The way we built it back is by using 1/4 inch steel rod, making a perimeter here, giving us a nice smooth edge so we won't ever cut a tire. But here's another modification. This is a chunk I cut out of the bedside, and it's pretty obvious where it went. The bulge went down this way. Here's what we're doing. We're going to create a functional air inlet duct that's going to go to a ducted tubing to cool the brakes. It's going to be very simple. It's going to draw air off of the outside of the body, duct it in. Because your brakes heat up, they go away. Project materials are inexpensive. 3-inch exhaust tube on 20-gauge sheet metal and a simple hole saw on a hand drill. What you're doing is trimming to fit and sinking your exhaust tube into the duct where you want the air directed. Trimming around the outside edge, well, we opted for a plasma cutter, but you could also do this with a pair of snips or a grinder. All right, so now we've achieved our goal of taking outside air and pushing it inside of the wheel arch, inside of the bedside. This is obviously not finished. We're going to cover this over and make a cool scoop. which starts with 20 gauge flat stock. Obviously, that doesn't look very good, so we're gonna dome this. And that ends up looking like this after a few minutes on the English wheel. And it ends up making a nice cover with a cool rounded edge. Now, we wanna finish this edge off. Two ways you can do that. Just like we showed you on the mirror base, you can make a buck and hammer form it around, or you can do exactly what we did on the inside of the wheel arch, take some 1/4-inch steel rod, hand bend it, and it makes a nice radius, makes a nice curved inside edge here, so that by the time you've got it painted, primed, welded back in place, it's a cool, sexy look that looks finished. It looks like a factory stamping. Now, just because we've got air going into the bedside doesn't mean it's going exactly where we want it to. We don't want it just to bounce around inside there. We want to control that air, force it onto the back side of the rotor, just like Carroll Shelby did. The way we're going to do that is very cool. Check this out. Now, just like up front here, we're going to be using functional brake cooling ducts by a company called Agent 47. Agent 47 is best known for their Fox Body Mustang high-performance road race products, which is perfect for our front suspension since, if you remember, we're using SN95 or Mustang front spindles. Since this system bolts right onto these spindles, it's absolutely a perfect shoe-in and a great project for this truck. The high-strength, heat-resistant corrugated tubing will allow us to duct anywhere we want to, which we're going to go into our new front fascia and finish off with these air inlet ducts, which we got from APR, who also supplied us with the custom carbon fiber race mirrors. Now, since this thing is going to get us from 0 to 60 in about 4 seconds, we want to make sure this thing stops as well as it goes. Cooling your brakes keeps your brakes. Well, as you can see, our air induction scoop is looking pretty cool. There's still some work to do. We've got some trimming and welding and then filling and then blocking and priming, etc. However, it's going to look cool, but more importantly, this is not some tacky scoop that we've thrown onto the side of the bodywork. This sucker is functional. It's going to really help with performance and keeping the brakes cool. Now, you guys that know Rangers, you know well that the fuel door used to go there. As a matter of fact, here it is. This fuel door, well, we're going to keep it because it's flat. We can use this in some other custom project. So that is going on the shelf. And this, for now, I don't know, we're pretty happy with the progress. Tell us what you think.
Now, most of what we set out to do today, we've accomplished. We've got fuel lines run, the superchargers bolted down, the engine wiring harness installed, we've got our coil packs dropped in, and we've added most of our front engine accessory drive components. But we ran into a little bit of a problem. These 03 and 04 Cobra engines were designed to go in a Mustang, and they had enough room for the alternator, which was supposed to go right here. Our problem is we got a frame rail and suspension in the way. Now, if you remember, we've gotten rid of the air conditioning on our Ranger, which means we don't have to run an AC pump, which left some vacant real estate on the lower passenger side. So that's where we found a home for our alternator.
The other project we're going to do today is deal with the byproduct of all of that power, heat. And I don't know about you, but riding around feeling like a burrito in a microwave is not my idea of having a good time on the racetrack. So we're going to deal with that problem. But we're not going to stack up a whole bunch of heat insulation tiles because, number one, they weigh a lot. And we're conserving weight on this truck, trying to keep the whole entire vehicle weight down. So we're going to show you guys how to use a product that is easy to prep, and get it just about anywhere, and doesn't weigh very much. Lizard skin. So why all the cardboard? Well, those of you who've been watching trucks for a long time, you might remember the 67 Chevy pickup Project Copperhead. Well, I painted that truck, top and bottom. And the way we're going to shoot the lizard skin insulation on the bottom of this truck is the same way I shot the floor pan, with the truck tipped back on the back of its cab. Cardboard, of course, is to protect the sheet metal. Work smarter, not harder.
Who put that thing in the way? That's one way to clean it out.
Thanks, guys. Now, there's a couple of things you notice right away with the cab stood up on end. The first one is, well, we've got a really good rust-free cab. The second one is this. That's the factory sealer. There's absolutely no sound or heat insulation on the bottom of this cab. And with the truck being low, the exhaust heat is just going to radiate up into the cab. So we're going to do something about that. We're going to scuff the entire bottom with these scuffing pads, and it's also going to give us the opportunity to give it a bit of a cleaning. The red scuffing pads you will find in every body shop on the planet, and they're the perfect tool for prepping this bottom since it's an inconsistent surface with lots of gaps. The prep solvent we're using for final wipe is also a body shop staple, but we got ours from Duplicolor, which means you can get it at just about any automotive retail store in the country. And it's always a great idea to chase out any solvents from your pinch welds or gaps with a little compressed air. Now, rarely does something high-tech come in a paste, but that's exactly what Lizard Skin is. It's a sprayable, water-based thermal barrier that's filled with ceramic particles. And just like your ceramic-coated headers keep the heat from out of the engine bay, this stuff keeps the heat from out of the cab. It's safe to use, it's environmentally friendly with easy cleanup, and it's even easier to spray if you use a kit that they also offer. The kit includes this siphon feed gun, which is all we're going to need today because of the way our workpiece is set up. But they also have this hose attachment that allows you to get inside door frames and tight crevices. And this attachment here that allows you to drop it down into the bucket, attach a piece of hose the length that you need to where you can work independently of the bucket with the gun body itself, if you've got a huge job. This is pretty necessary. This is included in the kit as well and allows you to stir up the paste and make it into a consistent format. Just attach it to a cordless drill and you're done. Now, it does require a little bit of safety equipment. It doesn't atomize or produce overspray, and it is water-based, but they do recommend that you wear a dust filter mask. Glasses come in handy if you're spraying upside down. We're not, so we don't need them. Now, we're going to do a little experiment today. Lizard Skin claims to be a lightweight thermal barrier, so the weight of the bucket is going to be measured before and after. Right now, it weighs in about 12 pounds. Now, we're masking for obvious reasons, to keep the Lizard Skin from going into places that we don't want it to go into. But it's not like a paint job, in the sense that all we need is 18 inches of masking paper to control the minimal overspray that we're going to have. The biggest thing we're masking for is the square chassis harness on the bottom of the cab and a couple of threaded bosses. Now, with the Lizard Skin mixed to the consistency of peanut butter, I've put it in the gun and I'm testing the gun pattern on a couple of places. Now, the gun, which comes in the kit, is a huge pressure-fed gun with a giant orifice. So the pattern is not going to be like a spray gun pattern. It's a round pattern and about 2 inches wide. But you can see how effective it is for this material. By the way, I've got my gun pressure set at 35 pounds at the inlet. Here, with the film in real time, you can see the thickness and consistency of the Lizard Skin paste. But that doesn't mean it's heavy. It's very light. The magic here is the ceramic particles that are loaded into the paste that literally deflect the heat from the surface that it's sprayed onto. We're going to be using 2 coats of the Lizard Skin on the bottom. The first coat is thick, the second coat is just as thick, which ends up giving us a consistent film and a nice, even texture. So now the bucket weighs 7 pounds. That means there's 5 pounds of material gone from the bucket. Just for the sake of argument, let's say we wasted a pound from cleanup, overspray, and overmix. So that means we've got 4 pounds of additional weight on the vehicle, on the floor pan. 4 pounds to give us a 30% reduction in interior temperatures. And everybody knows that less weight means the same thing as more horsepower. Now, even though the Lizard Skin looks great, it's really not designed as a top coat. So a coat of paint is really going to help seal the surface, seal it away from dirt, debris, and moisture penetrating the coating. The paint we chose is Duplicolor's engine enamel in semi-gloss black. It's easy to use, it looks great with a nice eggshell sheen, and it's got the same temperature rating as the Lizard Skin itself, 500 degrees.
Well, now that Kevin's got the floor of the Ranger completely insulated, we can move on with the installation of the parts that are going to make the heat in the first place, the exhaust system. Now, during stage 1 of this build, well, we built an exhaust system using a pair of MagnaFlow mufflers and some tubing we had around the shop using the bender we've got here. problem is that Bender doesn't produce Mandrel bends, so we wanted to upgrade and replace the non-Mandrel bent tubing with some Mandrel bent stuff that flows a little bit better and can support the higher horsepower levels this new engine's going to produce. So to do that, we picked up a universal kit from MagnaFlow. Now this 2.5-inch universal stainless steel pipe kit includes J-bends, 45s, 90s, plenty of straight exhaust pipe, ball and socket flanges, as well as about half a dozen exhaust hangers and a pair of O2 sensor bungs. So you've got everything you need to complete the system. Now speaking of which, while this stuff isn't cheap, you can usually get an entire exhaust system out of it, sometimes two. So if you play your cards right, you can stretch your dollar. Now we also picked up a pair of 2.5-inch stainless steel mufflers from MagnaFlow. Now these have a straight through design. There's no baffles and no restrictions, so they should provide plenty of exhaust flow. Now to complement this stuff, we're going to be running an X-pipe, but we're not sure which style will suit our application best. Now there's a number of benefits for running an X-pipe. We'll get more into that later. Now beyond all this new shiny exhaust stuff, we're also going to be reusing some of our old parts. Right over here. Now, if you remember, our exhaust system starts with a pair of 04 Mustang Cobra manifolds. They flow a surprising amount of air, and they're going to save us from having to fabricate a custom set of headers that we probably don't have room for anyway. Now, we're going to be reusing our high-flow stainless steel catalytic converters. They don't have that many miles on them. It just makes sense to reuse them. Same story with our O2 sensors. Now, here's an example of a non-Mandrel bent piece of exhaust tubing. Not exactly what you would consider show car or race car material. We are not going to be reusing these. Now the driver's side frame rail is awfully close to the output of the exhaust manifold, but we were able to sneak an exhaust pipe in there. And if we need to, we can go back later and relief cut the frame rail and plate it in, if we need to. For now, we're going to say it's good enough. Now, like we said, we were going to be reusing our catalytic converters, and we found the perfect home for them right on either side of the transmission. And that'll lead into the X-pipe, and you can see which style we chose. Now, an X-pipe has a few benefits. It'll change the overall sound of the engine and the exhaust by smoothing out the exhaust pulses. It'll also reduce the overall sound coming from the exhaust by a few decibels. And while that doesn't sound like much, your neighbors will certainly appreciate it, and it can make a difference if you're driving your car or truck at a racetrack that has noise restrictions.
Cool. Looking good?
Yep.
An X-pipe also has a scavenging effect, meaning that when one downpipe's exhaust pulse passes through the X-pipe, it helps pull the opposite downpipe's exhaust pulse through. Now we're just tacking this system together using our MIG welder, because it's quick and easy. But we'll go back later with a TIG welder for a nicer and cleaner appearance. Now, even though this is a performance truck and performance first, well, there's no reason it can't look good at the same time. And even though it's not going to be seen very often, we wanted the exhaust system to be as symmetrical as possible. Now the exhaust hangers came from the local parts store. We ended up having the perfect mounting location for them using this rear cross member. Now typically they're held in place by a U-bolt, but we wanted a cleaner look, so we ended up welding them directly to the muffler. Now we're going to take the easy way out, because I don't even want to think about running the exhaust through the IRS and past the fuel tank. Plus, exhaust out of the side of the truck just looks and sounds cool.
Now with the exhaust system mounted in the frame, we're going to drop the bed back down onto the chassis and get a really good visual idea of how this thing's going to look finished. With the bedside sitting down here, you can kind of see where we're headed with the body mods. Metalwork, filler, and some of the priming and blocking is done. You can see that it's really starting to take shape with the custom body mods and the wide body bedsides. By the way, 335/30 series tires have plenty of room between the bedsides and the sidewall.
Now, it's a good thing we didn't weld the tailpipes into position before we dropped the bed down onto the frame. They'd be both pointing right at the bed sides. Not good. So we'll get those adjusted, put them where we want, throw some good-looking exhaust tips on there, and call this system done. Now, another objective we had with this truck was to make sure nothing hung below the bottom of the frame rail due to ground clearance issues, because the truck just sits so darn low, and luckily we were able to achieve that. Now, the exhaust system does sit nice and low in the chassis, which keeps the weight down low as well. Now, we still got to come in here and wrap heat insulation around the downpipes, catalytic converters, and we might throw some around the X-pipe section as well, just to try to keep heat off the drive shaft U-joint and the transmission output shaft seal. Now, on the other side of the frame, well, you can tell we've been working on the brake lines a little bit. And that started out as a coil or roll of 3/16 stainless steel line. And we had to straighten it out by hand.
Well, we've shown you the bed sides on Rolling Thunder before with the modified sheet metal, the 1/4-inch steel rod, and the induction scoops in the bed sides. But I wanted to thank Tim Strange for kicking around a little bit and helping us get these things into primer and doing some body work. It's really nice to have a skilled set of hands like his when we need help and he gets bored. But in case you haven't seen what we did underneath this layer of primer, here's the metalwork involved. I found the center of the wheel arch and traced the line and started sectioning. Now, the next cut I made was about 1 inch south of the valley that stamped into the bedside. And it gave me a flange to work with that also lets me retain this stamped corner, keep everything consistent and smooth looking. Now, after I'd cut the inner structure out, it gave me the ability to pull the bedside out and expand all this metal and create the tire clearance that we needed, which gave me a gap of about 1 inch here and about 1 inch here. Now, filling in those gaps was a simple process of using 20-gauge sheet metal strips and just tacking them in place. And that gave us the clearance we need for full suspension cycle on these stupid wide tires. But it left the bed sides flimsy. That's where the 1/4-inch steel rod comes in. Just tacked it in place and finished the welds, gave the bedside back its strength. Now, it's one thing to walk you through it, talking about it, but we always want to show you guys what we do and how to do it. We've still got a huge problem on the front, and that's exactly what we're going to do today. Tell you how to get there from a bunch of cut-up metal. Now, up front with the wheel and tire locked about 2 inches above ride height, you can see with our altered wheelbase trick, we've got room for a lock-to-lock turn. However, at ride height or in suspension cycle, it's a different story. Okay, as the suspension cycles up, you get the picture. It gets ugly because obviously the sidewall is sticking way out. Even though this fender is trimmed and it's just a single wall and it's been flared out, there's not enough room for suspension cycle or even a lock-to-lock turn. So it's a pretty big problem, but it's one that can be solved. We're going to take the most basic and fundamental approach to expanding sheet metal, which is the pie cut. Cover up the expensive wheel. We're using a thin metal cutting blade we got from Industrial Depot to do the relief cuts. Now, what this allows me to do is to hand form the fender and contour it around my wheel without sacrificing the shape of the panel around the wheel lip. I've got an awful lot of time invested in the shape of the rest of the fender, and I don't want to sacrifice my previous work. All right, so we're going to trim a little more here. Make a relief cut there so we don't have a step. This is still in good shape. Now, it might look like I'm just shredding the fender, but there's a method to the madness, and we'll replace the strength later. All right, that gives me the tire clearance that I need for a lock-to-lock turn in suspension compression. However, this looks terrible. It's flimsy. That is not going to fly. It's not going to cut it. But this gives us the room we need. Now we build back the rigidity. The way we're going to do that is with 1/4-inch steel rod. This is available at any home hardware store, home center, or auto parts store sometimes, or you can buy your steel supplies online. The point is, it's cheap. This is about a $4 stick. Well, no, it's shorter. So it's about a $3 stick of steel. Let's try this. Okay, what you want to do is create a radius that goes around your wheel so you can tack it in place and give it support. Problem with that, a radius isn't round. It's got a peak there, and I'm going to end up making a mess. So here's an easy way to use what's right next to you to create your parts. We know the outside diameter of the wheel is exactly the radius that we want to put into the fender. So slowly use the tire and work it around like a die. You've heard me say this before, you're asking your steel or your metal to do what you want it to do. What that means is that you're not forcing anything and you're listening or feeling your way through making a bend like this. All right, well, I've got my arch. It's custom tailored to the wheel. Now, it's a matter of tracing, trimming, tack it in place, because you want the inside edge of this rolled steel up against the side of your tire. Just in case your wheel comes into contact with it, you don't cut a tire that way. Looks like we're about ready. One thing I want to do is cycle the suspension and make sure we've got enough room. Now I've got clearance here, but the steel rod that I'm going to put in as my wheel arch and the new edge is up about a 1/4 inch from there. So by the time this is locked in place, we'll have plenty of room for suspension travel, so we don't cut a tire, ruin our bodywork. With a 1/4 inch rod radius around the wheel itself, we actually use it as a template and trace around the single wall fender. This lets us use the strong points of the 1/4 inch steel rod, being that it's perfectly round and that it's quite strong. And again, we're going to cover up our expensive wheel while we make a lot of sparks. Next step is the very simple procedure of clamping the rod to the inside of the fender. Well, simple for some people. Hate when that happens. Okay, that's the stuff that you guys want to see that we never let you see. That's going in a show somewhere. So a slight strategy change, and I'm clamping it as I tack it. This also allows me to tack weld as I pull the fender out to where I wanted it to go. It has a tendency to return back to its original position, and you want to keep the flare where you designed it. If you've ever tried to MIG weld single wall sheet metal, especially late model panels, well, then you know you have the tendency to burn through quite easily. Well, here's a tip. Start your weld pool on the thicker piece of metal, then gradually ease it into the thin metal. Using that technique, you stand a lot less chance of blowing holes in your fender. And before we go too far, I wanted to cycle the wheel one more time just to check it for clearance. Now that's about as compressed as that wheel is ever going to get, and keep this in mind as well. Well, you can't see it, but I can. It's cambered out. We haven't done alignment on this thing yet, so it'll be tipped in even more. That's tons of clearance. So the only thing that's left is about 1 million tack welds. Ryan? Now this is a lot of tack welding, so make sure that your skin is reasonably covered with a long sleeve shirt or welding sleeves like I've got, so you don't get that annoying sunburn. That's the tacking. Now I gotta grind it down, and then we start body work. Ha! And then do it again on the other side. And this is our altered wheelbase, stretched, flared, and trimmed new fender that solves a whole ton of problems. Now, our main goal here was to make this appear like it hadn't really been changed all that much the first time you look at it. But the truth is, it's been changed a ton. And here's what we changed. The easiest way to gain clearance on a fender like this is, of course, to sacrifice this lip. And trimming that, well, we gain 2 inches. And by pulling out the rest of the style line, we gain another 1/2 inch. And by doing the pie cuts across the fender, we gained another 3/4 of an inch. So that gave us, well, a little bit better than 3 inches on each side of the truck of extra clearance for our new track width. Now, the metalwork isn't perfect, but I'm very happy with how it turned out. We didn't warp the sheet metal very much, and it needs some filler. So between fillers, primers, and some blocking sessions, we're about 8 hours away from having these front fenders looking like the bedside. And that means this truck is that much closer to having paint on it, which means that it's that much closer to us being able to drive it. I know you want to see it, and I do too. Now, we've got a ton of stuff to do, but we don't want to gloss over all the good stuff. We want to show you guys some good, solid tech. Part of that is the paint and body process. Now, we've got some of the panels primed, but we've still got some damage here on the hood in the form of some mild hail damage. Now, we're going to show you a process today that you've probably never seen before, and it's an unconventional way to take care of damage like this. It's cool, so stick around. Now, the first thing to do is clean off your surface. This is done with a simple glass cleaner. And of course, to apply primer, whether you're spraying it or pouring it on like we are, you have to abrade the surface, which means putting scratches in it, so the primer has something to hold on to. Now, we located the dents earlier by using the shiny paint and the reflective surface, but you can clearly see where the low point of the dent is when you sand over the top of it. Doing the crosshatch does two things. It literally shows me where the low point of the dent is, and it makes sure that I've got it scraped up and scratched enough to hold the primer. If you've ever done body work before, you know that there's something missing. I'm not wearing a dust mask. That's because there's no dust suspended in the air. Now, when you're mixing the rust defender, it's pretty darn easy. There's 4 quarts in the can, and there's 4 divisions on the side of the catalyst bottle. Since we're mixing only 16 ounces, I'm mixing a half of a measure of the catalyst in, just to be precise. Now, after you've thoroughly, and I mean thoroughly mixed in your catalyst, well, you're ready for your application. And our application in this case is pouring it on with the help of a 98-cent ketchup bottle I got from the local grocery store. Now, the liquid primer surfacer, when it's poured onto the dents, is going to flow out on its own. The industry term for this is self-leveling, and it does it quite quickly, so you have to be aware that your hood is as level as possible. And what we're doing, it's not rocket science, it's self-explanatory, and you can literally see what's happening. Now, as thick as this is, it's not going to dry instantly. It's probably not going to dry in the recommended dry time. So we're going to leave this stuff overnight and come back and block it out and see how we did. Now, since we have an excessive amount of surfacer mixed, we're going to do a couple of different fun things. We're going to put our cake batter on our mirror bases. Now, there's no technique here. It's just pouring the stuff on. However, on a vertical surface like the door and the cab corner, well, we need to repair the dent with conventional filler first, and then use a different application of the surfacer. We're blocking the finishing putty with 80 grit on a soft sander. And once you're satisfied with the repair, you're already set up for your surfacer, which this time will be applied with a roller that we got from a home center for about $1.50. Now, like we said, with a vertical surface, it's a bit of a challenge, but the primer does build pretty good, even with this application. Coat number 3.
Well, while we give Kevin's primer a chance to dry, it'll give us a chance to tell you about the gauges we're going to be using in Project Rolling Thunder. Now, they come from Autometer, and it's their Elite series of gauges. Now, these are full sweep electric gauges, and they're not only very precise and accurate, but they're also quite functional. Now, just a few screws hold the one-piece clear plastic lens and black gauge bezel to the instrument cluster. Then we popped out the gauges themselves, which are just kind of pressed into the housing. And with that done, we can flip it over and remove all the warning and indicator bulbs and rip off the printed circuit. It's just not necessary. Then we simply made a cardboard template and marked which side faces up. And here's how the aluminum panel will fit over the cluster, but we've clearly got a problem because the gauges need room to recess into the cluster, so we're gonna have to make a little bit of a modification. So I just use a small drill bit to locate the approximate center of the gauges and the clearance they're gonna need. Then I could use a hole saw to open things up a little bit. Now, these probably aren't gonna be opened up enough, but the plastic's easy to work with and I can go back later and trim as needed. Well, that looks kind of destroyed. That's what we want, we just need this plastic chassis. Now, the cool thing about a project like this is that the gauge style, the material you use, and the gauge layout is all up to you. All right, with that done, we're gonna run into our second problem, and that is, well, obviously, we need to remove the trim bezels for the factory gauges, and we've got to get rid of the clear plastic, because, well, these have clear plastic on them themselves, and we need access to the programmable buttons. So, after quickly removing the clear plastic lens, we could get to work modifying the gauge bezel. Now, what I'm doing is using a razor blade to create a score in the plastic, deep enough so when we go back with a pair of pliers, it'll give us a nice clean break and we can get rid of the excess. What we end up with is exactly what we wanted. All right, well there they are. Now we still have some work to do to finish mounting the gauges, and we obviously have to finish wiring them up, but you get the gist of it. And I gotta say, I'm really happy with the way they turned out. They've got a nice clean appearance, the gauges are in a stock location so you know you can see them easily, and they've still got an aftermarket or racy look to them, which I think is kind of cool. Now you can do this whether you're working on a late model truck like we are, or if you're working on an older pickup truck and you want to combine stock instrument cluster components with accurate aftermarket gauges. As far as the mounting panel goes, well, we're just going to leave the aluminum panel raw, but you could cover it in any number of materials or paint it to match the rest of the truck. Just get creative and have fun with it.
Well, I know that you or somebody in your family has gotten one of these for a gift. And you don't want to hurt the feelings of the person that got you this gift, but you don't really know what to do with it. Well, don't worry, I'm going to help you out. Because today, we're going to show you how to make this out of this. I'm not kidding.
Yeah, well, while Kevin's turning his highly coveted Christmas gift into a custom bumper, I'm going to be doing something else. Anything else. Maybe painting this frame. I just hope he's wearing more than his birthday suit under that thing. Whew.
Well, to answer that question, yes, I am fully clothed underneath my super comfy Christmas present. And to get it right out of the way, right from the start, our custom bumper is made with a combination of fiberglass and fleece. And the end result is a custom molded bumper with an aerodynamic shape, a cool little kick out here, and enough real estate to house the APR carbon fiber inlets for our brake cooling ducts, as well as maybe even some real estate for some kind of a fog light down the road. And all of it is bathed in the high build polyester surfacer that you've seen us use quite a bit here on Power Block. And it all starts with a stock bumper and a wireframe. Now, the stock bumper is a stamped steel upper combined with a plastic lower, and it didn't really have the look we want. We looked through a bunch of catalogs, and we still didn't find anything that would suit the rest of this truck, especially the custom bodywork. So, it's trucks. We decided to make our own. And of course, it starts with a stock bumper, and then I built a wire form to give the shape that I wanted. And I did this while the bumper was on the truck to give me the ground clearance I needed and the overall shape. You could stand back, kind of scope it out and look at it and really perfect your design. But I didn't start with a 1/4-inch steel rod. I started with TIG wire. You can see pretty much exactly how this thing kind of fell into place. The TIG wire is easy to bend, and I could experiment, and I could do a bunch of different shapes and see where it started and just MIG weld it together and easily come up with my form. And then transfer these shapes onto the 1/4-inch rod. The 1/4-inch rod is a little bit difficult to bend, and it's not nearly as forgiving as the TIG wire. So let's talk about that. By the way, a coat hanger works great for the same type of a project. It's easy to bend, and they're cheap. You can do pretty much any shape you want. I stole a bunch of Ian's TIG wire, and I like the straightness of it. But we ended up using 1/4-inch steel rod because it's the same steel rod we use on the fenders and the bed sides to make the inside radius and to build the strength back into the panel. So kind of a common theme. But there's a lot of different thicknesses and different types of stock available to you. For instance, 7/16 and 1/2 inch. But as they get bigger, they get heavier. So the compromise was 1/4-inch gives us the weight and the ease of construction that I was looking for to make this project. But like we said, the steel rod is a little more difficult to bend. That's where Matco comes in because they've got some nice tubing benders available. This guy has longer arms and you can bend up to 1/2 inch diameters. This is what you typically use for brake lines, and it works good for the steel rod too. Got to man up a little bit though. You can, but it's probably not the best. Oh, there we go. It's a bit of a challenge. So you can imagine making that radius by hand. It's a little bit more difficult to do. However, you can get it done with the tubing benders. But if you don't have them, here's an inexpensive way to make some simple forming dies. If you've got a C-clamp and something round, you can rock and roll. This, for instance, is a pulley off of the 4.6 that we pulled out of the Ranger to put the new Illuminator in. And it's obvious what you can do. You can literally use it to pull your forms around. Even when it's coat hanger or TIG wire that you can easily bend by hand, you can use this guy to make a smooth radius that's perfect rather than one of these that's going to be inconsistent. So it's a great tool whether you have the tubing benders or not. Here's another thing to remember. You saw me bend this with the tubing bender, but if I try and do it on my homemade die, I can't do it. So here's where you can use leverage. It's simple physics. We've just got a longer piece of the same stock, and I can use the leverage and easily bend around like so. I can make a nice consistent radius that way. So keep that in mind when you're trimming pieces. You might waste a little with the longer stock, but you're going to get the radius and the bends that you want. Now I've got all the metal prepped with 24 grit, which is very aggressive, but we need a good, strong mechanical bond. Well, here's the big secret. The reason this thing is so comfortable and flexible is because it's made out of fleece. And fleece has the amazing property to where you can stretch it and it retains the shape of what you're stretching it over. That's why guys doing pro audio projects use fleece, stretch it around wood forms, and it retains the shape once you add the fiberglass resin. Those guys use staples. We can't put staples in the metal bumper, so there's some other supplies and materials that you're going to have to use. Obviously, you're going to need some kind of fiberglass resin. We just got this from the local auto parts supply store, and it usually comes with its own catalyst. Now, I've got this giant nut and bolt and some unwaxed dental floss. Hang in there. I'll explain what this is about later. Scissors to cut the fleece. Little single-edge razor blade helps to get in some tight corners, and disposable brushes, since the resin is pretty much going to make these useless after it sets up. You can use clothespins to hold things in place. However, they don't hold much tension, so we're going to use these binder clips. You can get these at any office supply, and they're stronger and they'll hold more tension than these guys. Now, this project is not quite as messy as working with traditional fiberglass matting. However, it's fiberglass, it's messy, so glove up, protect your skin. Now, this is a pretty fun body shop project, and it's really forgiving. The fleece doesn't really care which orientation you lay it down. You're kind of sneaking up on it and pinning one side to stretch the other side. It doesn't take a whole lot of force, but using multiple clamps gets you an even tension and a more even shape. What I found worked best for this bumper was to pull in opposite directions. For instance, we've got the top or the bottom, now we're working side to side. In particular, the inside of our air inlet as opposed to the outside of the bumper edge. And the beauty of fleece is that it conforms around corners, and you can really dictate the shape that you want just by stretching it in different directions. Now, here's where the unwaxed dental floss comes in handy. Basically, what you're doing is opposing the tension that you've created in the wire form. I'm tying it at one end and weighting it down with a giant nut and bolt on the other end. It's pretty obvious what it's doing. It's creating my cool little kick out. Now, the unwaxed part of the dental floss allows the resin to permeate the floss instead of sitting on top of it, so it literally becomes part of the bumper when you apply the resin. The mix ratio for your fiberglass resin and catalyst is obviously on the side of the can, but if it's really hot, you want to put a little less in. If it's very cold, you want to put a little more in. The point is mix it thoroughly once you've got your catalyst added to the resin. Now, this is the fun part, and there's really no skill or talent involved in this. You're simply brushing the fiberglass resin onto the fleece. Be careful, of course, not to put too much on and disturb the shape. Now, if you wanted to, you could put it in a large orifice spray gun and spray it on. I just find it's a little more therapeutic to do it this way. Okay, we let the resin set up for a couple of hours. Now we're going to try and take some of these clips off. And sometimes you get lucky and they just pop right off. Now, these clips are thankfully cooperating. However, if you can't get them out of the resin mix, don't worry. They can be ground down flush and covered up with filler, since we are going to be using filler for the final shape. Then we've got a couple lumpy transitions here that we're going to smooth down with a grinder. This is the reason for the heavy-duty 24 grit scratches into steel. It allows the resin to make a nice mechanical bond and stick to the bumper. So the next step is to cut the hole for our cool carbon fiber air inlet duct for the brake cooling vent. We got these from APR, and since they're universal, the same size hole goes on the other side, and that starts making a template. Now this is the same basic principle as doing a mirror image of a graphic on a paint job, like a flame job. I've crimped the edges so I know where my paper wraps around the ends, and I'm simply using a spray can instead of a pen to mark the shape of the hole from the backside. We take that, transfer it to the other side. In swapping it over to the other side, I'm also flipping it upside down, so we have a literal mirror image. Using the sides that I folded over to mark, as well as some masking tape, and locating it in just about the same spot. I say just about because it's not really rocket science that we're working with here. I want to get it close, and then eyeball it, and then make my final adjustments as I sneak up on it. Now, rather than run a pen around an inconsistent edge, I'm using the spray can again because it gives me a ballpark idea of where I'm going to start trimming. The marker just gives me a clearer idea of where to cut when I'm trimming for the opening. One final check with a measuring tape and comparing it to the other side lets me know that our template is exactly where we needed it to be. Yep, we're in the ballpark. I'm actually using an angle grinder and a 36 grit cutoff wheel to trim the opening. The fleece is thin and it's soft, and this gives me more control around a radius. Here's where the inlet scoop itself becomes a template. I'm simply using a marker and marking the holes precisely where they should be. I start off with an 1/8 inch drill bit and make the hole slightly larger. This side fits. Gonna build that up a little. Now, since the inlet duct is flat and the surface of our bumper is curved, we need to build up the edge just a little bit for a more flush fit. I'm using a fiberglass reinforced filler made by Clausen that we picked up from our friends at Autobody Color and Supply. Before the filler sets up completely, I'm shaping it with 36 grit paper. This allows me to move quickly and easily and establish the shape that I want. The fiberglass makes it strong. There we go. Now here comes the tedious part of auto body repair, which is basically using filler and blocking and filling and blocking and filling and blocking again. Keep in mind though, with this project, the fleece establishes the shape. All we're doing is a thin skim coat of a finishing putty, no more than a 1/16 and maybe an 1/8 of an inch thick. I'm using 80 grit paper to block it out and really just refining the shape, filling in any cracks or pinholes that may be there, and quickly getting it ready for primer surfacer.
Well, while Kevin was eating popcorn and lounging in fleece, I had a chance to completely coat the frame of Project Rolling Thunder with POR. And in the areas where I couldn't get a brush, I'm just touching it up with some rattle can spray paint and get rid of the rust color on the inside spots. Now, we didn't end up with a show car quality finish because we brushed this stuff on, but that's not what we were after. We wanted something tough, something that could stand up to the rock chips. And this truck sits kind of low, it's going to see plenty of them. Plus, POR is easy to touch up. Now, speaking of which, we didn't leave any bare metal to weld the coilover mounts to. That's no big deal. When the time comes, we'll grind it down to bare metal, weld in the new mounts, brush in some POR, blend it in, make it look nice, and call it done. And with the frame completely coated, we can finally start the final reassembly of this truck. Now, hanging off the front of the Ranger is something we haven't shown you before, and it's the mounting bracket for the heat exchanger to cool the supercharger. And it's just small diameter square tubing, 20 gauge sheet metal bent up, and it's attached to the body with rib nuts or nut certs, so it's removable. And with it sitting down nice and low, well, it's not going to interfere with engine cooling or the radiator, and it'll be protected by Kevin's custom-made bumper that he used a genderless man robe to make.
Now this is just a mock-up. We haven't really started assembling yet, but we wanted to show you what the bumper looks like. One thing we haven't showed you is the air inlet opening for the heat exchanger. We didn't want to leave it exposed, so we used another scrapped Ford Ranger grill and just made the insert fit the opening. It just screws in from the back with some tabs we added. Project Rolling Thunder, final assembly. All the body work's done. It's in high build primer. 95% of the fab work is done. Most of the parts are here. So it's time, and we're happy about it. There's still a couple of things that we're going to do today, though. For instance, these are the slugs that have established our ride height right from the start. Well, obviously, our coilover suspension is not quite complete, but we have to fully assemble the vehicle and get corner weights to properly gauge the spring rates and even the spring length. So that's one of the projects we're going to do today. So stick around. It's going to get fun. It's going to look like a truck.
An 03 Mustang Cobra provided the independent rear suspension that we're using on our Ranger. Now, grafting it into the frame rails took a little bit of work, but it's in there good and solid with 6 bolt-in points, as opposed to the factory 4 points of attachment. Now, up front is our custom front suspension using factory 5 lowers and circle track uppers. The brakes are from Ford Racing, and they ought to do a pretty good job of slowing down this Ranger. Now, the brakes sit on late 90s Mustang spindles. And that's also the same make and model that provided the steering rack. Now, the steering rack does have adjustable bushings from Maximum Motorsports, so we can try to dial out any bump steer issues that we may have.
Now, one of the benefits of having a body-on-frame vehicle is access to the plumbing. And the brake line that we've sourced from Summit Racing was bulk line that comes in a spool and was hand-bent and straightened to meet our application. The fittings are AN adapter fittings from Russell, and we've also plumbed in a proportioning valve for brake bias adjustment. Ryan also drilled and tapped the frame to accept the clamps for permanent installation. Out back, our fuel cell, custom made by Rick's Tanks, drops into place. The transmission crossmember was custom made to fit our application, and we made it removable for easy access if we ever have to do any maintenance. The whole engine and transmission assembly drops into place, and this shows the beauty of mock-up. Yes, you're going to take it apart 100 times, but when it goes back together the final time, it's easy. And just in case you forgot, this is a Ford Racing 4.6 at about 650 horsepower.
Now, the heavy battery was relocated to the back of the truck, mainly for weight distribution purposes. Because every pound we can take off the front of the truck and put over the rear wheels will only help plant some of that 650 horsepower. Now, the battery cables themselves are lightweight cables. They're aluminum strands coated in copper to save weight. Our positive cable routes to the cutoff switch inside the cab, and the ground strap simply bolts to the frame. We'll leave the ground loose just in case till we get everything hooked up, and then we'll connect it. That can just dangle there for now.
The drive shaft is custom made by Denny's and is more than capable of handling the horsepower, torque, and RPM of our application. The larger diameter is to increase strength, and the lightweight aluminum construction is to decrease the rotating mass. The drive shaft safety loop may be a little redundant with the crossmember right there, but it also keeps the track officials out of our hair. The fuel lines are routed to the custom 4 Precision fuel pump and connected with AN fittings into the Russell braided nylon line. The AN fittings allow us to easily serve as fuel filters and break the line up to where we can route it through the frame rail, which is hollow, but a little bit of a challenge with it fully boxed. So we cut an access hole right behind the engine and routed the fuel lines up to the back of the rails from there. If you're doing this at home, make sure that your route is clear with no obstructions so you don't damage the fuel line.
All right, with our True Forged wheel and BFG tire combo on, all we've got left is to add our exhaust system, and we're gonna have a complete rolling chassis and drivetrain. And then we can get started adding parts to the interior of the cab, and we'll have this thing closer to final weight.
Now, these Ford log-style manifolds flow really good, ask any Cobra guy. But we had ours sent to nitro plate for ceramic coating inside and out that looks great and keeps the heat out from under the hood. We were able to reuse the downpipes from the Stage 1 Marauder swap, but the new MagnaFlow stainless steel system gets bolted up to an existing cross member. And it fits great, but boy, it's tight. We got clearance in the universal joint?
Oh yeah.
Woo, that's close. It's
Quarter
clear
inch.
though.
Quarter inch.
We also had our side exit exhaust tips coated in nitroplate, since they were a mixture of mild carbon steel and stainless. These get installed temporarily. What do we do without zip ties?
I don't know. What did the world do prior to zip ties? You know, they hung down a little bit. That's probably about right. Yeah, that looks cool.
Now you guys haven't seen the completed interior. We finished things off by spraying some lizard skin sound insulation and then covering it with some Duplicolor New Ford Gray spray paint. Now our 5-point harnesses have 5 points of attachment to the vehicle or the roll cage. We've got 2 shoulder straps that wrap around the harness bar and get triple wrapped to the bar, 2 lap belts that get bolted to either side of the seat, and a 5th strap called an anti-submarine strap that will pass through a hole in the seat and get bolted to the floor. Now we use double shear mounts and plenty of Loctite at all harness attachment points.
Now you guys that haven't dealt with multi-point harnesses before might be wondering, what do I mean by triple loop these harnesses? Well, it's just that. It's 3 passes through the adjuster. We're already through once. We went around the harness bar. We're going to pass through the adjuster one more time. This is where you might make the mistake that, well, that's good enough. There's no way that's going to come loose. But in a high G impact, well, that could be enough to draw this loose, and you could find the dashboard. Not cool. So you take the belt, pass it back through the adjuster, which can be kind of snug, fold it over the back, and now it's locked in and triple loop.
Now, since there's no adjusters on these seats, the placement was carefully thought out and mocked up several times before choosing the final placement and tying them into the roll cage. Besides, the padded seat covers will give a certain level of comfort as well.
So we dropped the bed back onto the frame and rolled it and the chassis back over to the lift so we could drop the cab back on this thing and get some final corner weight numbers. Finally, here it sits at ride height and almost completely assembled. All we're missing is a windshield, installing our coilovers, and doing some last-minute plumbing and wiring. Then we can fire this bad boy up and take it to the track so it can flex its muscles. Now under the hood, well, we're just about finished up. The only thing we've really got left to do is fill this engine with fluids and get a reflashed PCM installed. Now we've had a chance to get upper and lower radiator hoses on this thing, get the plumbing for the intercooler and heat exchanger taken care of, and get our supercharger drive belt on. We've also buttoned up the wiring, filled up the brake reservoir and clutch reservoir, and mounted our fuel pressure regulator to the Firewall, along with running all the lines.
Speaking of fuel, we wanted to show you something that we've revised since the last time you saw it. We used to have the fuel cap mounted in this aluminum plate, and we were going to hard mount it to the bed floor, but we got to thinking, this is going to see some pretty aggressive driving and possibly some track time. And if the event happened where something bad went down, we got into a collision, well, now we've locked the bed and our fuel neck together. So what we did is just cut a larger hole in the floor, make a little neck on the fuel tank, and isolate and mount the fuel cap right here. We've got plenty of clearance around the bed floor, and we've also ensured that there's not a spark risk right at the fuel vapor contact point by using vacuum line and some weather stripping adhesive and kind of sealed it up. It doesn't look bad, and we know we're going to be safer on the road.
Now the original Cobra independent rear suspension anti-roll bar or anti-sway bar mounted on the backside of the subframe and behind the differential, but it interfered with our coilovers, so we had to lose it. What we ended up doing was recycle the truck's original front sway bar, and we've got it installed on the front side of the differential where there's barely enough room. Now we made some custom brackets for it to hang it off the frame and picked up some PosiLink end links from Ride Tech and attached it to the lower control arm's original sway bar mount. Now this sway bar is a little bit larger diameter and has shorter arms, so it's going to be even more effective than the stock Cobra sway bar at reducing body roll. Now our crate engine came to us brand new with 0 miles on it, and I'm sure it was put together with assembly lube and all that, but it has been sitting for a couple of years both in and out of the truck. And the last thing we want to do is turn the key for the first time and have metal-to-metal contact or a dry start causing a lot of engine wear. So we're going to make sure the engine oiling system is fully lubricated before we do that. We're going to be using this Goodson's pressurized pre-lubrication oil tank. Now, you guys might be a little bit more familiar with this oil pump drive shaft tool. One end hooks up to an electric drill, the other engages the oil pump, you spin it, and it circulates engine oil. But on vehicles or engines without a distributor, that's just not an option, but you still want to prime the system.
Now, we've got this tank filled with a couple of quarts of Royal Purple engine break-in oil. Now all we have to do is pressurize the tank with some air and hook this line up to a fitting near the oil filter. Now, step one is disconnecting and removing our Autometer oil temperature sender and installing this brass adapter. This elbow will allow us to install another adapter that we can hook the line to. After snugging down the line, it's simply a matter of pressurizing the tank with compressed air. We took it to about 60 psi.
What's that?
Then slowly crack the line open and let the oil flow into the engine.
And since our gauge is still hooked up, we can just put our eyes on it and confirm that pressure is building in the system. Now, we've showed you what we did for an anti-roll bar or sway bar on the rear of this pickup truck, but we haven't shown you anything up front. It's because we haven't installed one yet. Now, when selecting a sway bar for this custom application, well, we don't want to just grab one out of a catalog or go with what our buddy runs down the street. We want to know for sure so we can get the right spring rate for it. Now, there's a few key pieces of information you need to have when selecting the correct spring rate for the sway bar. One of those being the center of gravity height. Now, you've probably heard the general rule of thumb that the center of gravity height is about where the shifter handle sits or about the height of the camshaft in the engine block. But those are probably more suited for car applications. So rather than go with a general guideline, we're going to take some measurements and know exactly where it sits on this truck. Now, the first step is to get a baseline measurement of what the truck weighs at all four corners with it fully dressed and sitting at ride height. Now, the information we're really interested in is the weight over the front of the vehicle, which is about 1,826 pounds. Now, for accurate results, you need to lift the back of the vehicle at least 10 inches. We went up as high as we could with our floor jack before resting it back down on the scales. We did let the pressure off the jack, it's just there for insurance. Now, the computer program we're using wants to know the rear axle center line. Ours is 24 inches. So by lifting up the rear of the truck about 11.5 inches, we've got a new front weight of 1,851 pounds, an increase of 25. All right, now in addition to some of the measurements we've already taken, the software needs a few more bits of information, like the radius of the front tire, the radius of the rear tire, along with the total of the front vehicle weight and the rear vehicle weight with it sitting level, and again, the front half of the vehicle weight with it tilted up. With that entered in, let's see what we get. Now, there's a number of center of gravity calculators easily found online, but you may want to run your numbers through more than one just to verify you get the same results. And with all the info entered in, you let the magic box do all the boring math. Ours turned out to be a pretty respectable 21.7 inches. Our truck's wheelbase is about 117.5 inches, and we've got about a 54% front weight bias. 54% of 117.5 is about 63.5, putting our center of gravity or center of mass 63.5 inches in front of the rear axle center line. Now, our center of gravity height turned out comparable to a lot of performance cars, which is pretty good considering we started out with a pickup truck. Now, we'll take our center of gravity height measurement, combine it with our front and rear roll center heights, our spring rates, and the specs on the rear sway bar, and we can determine the correct front sway bar. And we'll get the right one right out of the box, instead of going through the expensive trial and error method. Now, this COG height measurement is also useful in a number of other suspension and automotive calculations. So if you can get your hands on some scales, it's worth doing.
Well, we got the computer back from Jeff and the guys at Done Right Performance, and based on the information we sent them, mass air meter specs, injector size, etc., they reflashed the computer with a tune that's going to be good and safe to start and run. Now, down the road, we can get a full chassis tune on this thing, but now we finally get to hear what it sounds like. All right, fire it up. You've got to love the sound of a supercharger, and this thing sounds healthy. But those of you who have done major projects, well, you know that there's still a bunch of work to do on this truck. We got to nut and bolt the entire chassis, there's still a front sway bar to put on, plus there's several adjustments that we've got to go through and tune this thing and make it handle as good as it looks. But rest assured, we are real close to some awesome seat time and hopefully making a lot of tire smoke. DBR High Performance specializes in all makes and models with a focus on improving performance. And co-owner David Branson was born to run this shop.
My dad did repairs as a kid, car repairs. He had a little import shop. And I just grew up, I loved working on stuff. I loved taking something that was broken and fixing it. And I learned that I could take something that wasn't broken and make it better. And I like that even more.
The entire staff at DBR are serious hot rodders, using a get-it-right the first time approach that starts from a solid foundation of fundamental skills. That and the stellar local reputation led us straight to their front door with Rolling Thunder.
When I was in college, I worked for an import shop, just doing oil changes, minor repairs. And then out of college, I worked for a shop doing custom work, and then I worked for Mercedes-Benz for a couple years, just as a service tech.
David's version of the American dream was to open up his own high-performance shop, but nobody ever told him it was going to be easy.
Me and my business partner talked about it, prayed about it, and we finally decided to open the doors. And we've been at it for a little over 4 years and built a lot of cool stuff and had a whole lot of fun doing it.
Now, when we first called David to talk with him about Rolling Thunder, it was obvious that the project was a little unusual.
That's just cool. It's weird. It's so weird, but in a really, in a really cool way. My first reaction was a Ranger with a Terminator. I just couldn't put the two together. I just pictured like a dirty Ranger with a Terminator in it, spinning tires with rust falling off. And then once I got more educated with the project, just all the work that's been put in, the lengthening of it, the fenders, the suspension, super excited about being able to be a part of it. I can't wait to see it, actually on the track.
It's done. We're ready?
We're ready. First thing we did when we got Rolling Thunder was just do a basic check over the vehicle. Found a couple things we needed to fix right away, got those kind of in order. Turn the power on. With John Lund with Lund Racing, we developed a calibration to get the thing started.
So we got a new mass airflow sensor on here. Can you tell me about that?
Yeah, we chose to use the BA3000 from SCT. A stock meter would max out at this level. The BA3000 allows us to calibrate the vehicle correctly, and the math tables don't max out, so they don't go into the failed tables. Once we had the thing started and running, we dialed in the idle.
Idle sounds real good.
Got the idle tuned perfectly.
Now, one of the final steps before making our dyno pull is making sure that this lab-grade lambda sensor or oxygen sensor is calibrated to the ambient air so we know we're getting good, accurate readings.
DBR even has an in-house weather station, which really helps dial in precise calibrations.
Ready to fire up?
Let's get some heat in this thing.
We're gonna start and make a pull from 2,000 to 4,000. If we like what we see, we'll go from there. If not, we'll make some changes, go from there. We kind of take baby steps. We look everything over. We look at the boost, we look at all the temperatures, we check the belts, we check the drive line to make sure everything's okay. With the help of Lund Racing, we make changes based off of what we saw, and then we make another pull, usually 2,000 to 5,000. On and on and on until we get to the rev limit of that vehicle, until it's done. So taking baby steps is a way to prevent accidents. The finished product is we have an SCT handheld that you're gonna have two different tunes on.
All right, on a street and track tune, we're looking pretty good. Now he's got it set up making a lot of torque on the bottom end, and our horsepower curve looks great, and it's still rising when he shuts it down. Look at our numbers. 522 horse at the rear wheels, 525 pounds of torque, 11 pounds of boost. Rock and roll. I want to drive this thing.
The potential you have is you're barely touching the surface. We're only at 11, 12 pounds of boost. That engine, you could easily run 15 to 17 on pump gas. If there's anything that I could do differently on this build, it would probably be a bigger blower, just because I like to go fast and I like stuff big and fast. So that's about it though.
All right, now on a pump gas drag tune where he added a couple of degrees of timing, this thing responded by making 550 horsepower and 540 pounds of torque. So needless to say, well, we're beyond psyched, and we're gonna have to flip a coin or arm wrestle or something to determine who gets to drive this bad boy home.
We were very pleased with how we were able to accomplish the goal for this truck. I feel like the calibration that's in it's gonna be very safe. You're gonna get a lot of fun out of it, and there's tons of room for potential.
Well, Project Rolling Thunder survived its maiden 20-mile voyage back from getting custom dyno tuned. And cruising down the interstate, well, the engine was running nice and cool, and at highway speeds, it was only turning about 1,800 RPM. Nice little cruise, until you put your foot into it. And then you better be holding on to its 550 horsepower. And since this truck's just about done, well, we wanted to share with you the final stats on this monster. We built this truck around a 4.6-liter dual overhead cam Illuminator engine. That's fed by a 2.3-liter supercharger strapped to the top. Behind that sits a lightweight clutch and flywheel assembly and a 6-speed manual transmission. The rear suspension is unique to say the least. It's a beefed-up Mustang IRS. The front suspension was designed on performance trend software and then applied to the truck. Triple adjustable coilovers will allow us to dial this thing in. Some 13-inch rotors and 4-piston calipers up front ought to slow us down. Now we roll on some 3-piece true forged wheels, wrapped in some pretty sticky and pretty wide BFG G-Force KDW tires. All this adds up to just under 3,400 pounds with a low center of gravity and a respectable front rear weight bias. And finally, moving this thing down the road is a thundering 550 horses at the wheels.
Now, as bad as this truck is, believe it or not, there's room to pull more power out of this engine, a lot more. Simple things like a pulley swap, heck, even a larger displacement blower, throwing more timing at it with a higher octane fuel. But for our money, it's finally time to find the appropriate road course to really stretch this project's legs and find out what it's capable of. And I don't know about you guys, but after more than 2 years in the making, we think Project Rolling Thunder is ready. So are we.
Now, Project Rolling Thunder, while it is street legal, is a little too intense for a full throttle street or highway test. We needed to come to a place where we could really open this thing up and see what it could do. All right, now we're up here at a wet Nashville Fairgrounds Speedway, and this truck's only seen street miles, so we want to be cautious, give it a few warm-up laps, take it into the pits, make sure everything's good to go. Then we can suit up, hope the track dries out, and give this thing a real workout. Now, a wet racetrack, 600 horsepower, concrete retaining walls, and a freshly built and kind of expensive pickup truck usually don't mix well together. So we're taking it easy, making sure no parts fall off, and keeping one eye on the gauges before we get too serious. Now, a few warm-up laps also gives us an opportunity to get acclimated to the truck, to see how it feels when we're fully strapped in. We can get used to the brake, the clutch, the throttle, and the steering, and get a good feel for the truck and how it reacts at speed. So you can do things on a racetrack you just can't get away with on the street.
Well, so far the truck is doing great. No worries, no concerns. And we've proved that we can go in a big circle and turn left. But Rolling Thunder was built for a heck of a lot more than that. So a couple of little adjustments on the front sway bar and the brake bias. We're going to throw some curves at this thing.
Once we finished suiting up with the safety gear we picked up from Summit Racing, we were able to get a little bit more aggressive with the truck and try to tap into its 600 plus horsepower. Now, trying to put the power down after running through a puddle can be difficult, but judicious application of the throttle will put power down without making you spin out. You just got to be careful. Now, this truck is not set up for a banked paved oval. It's just not a circle track truck. it's set up more for a road course. So we're kind of limited on how much speed we can carry through the banking just based on the suspension setup and alignment. But on the flat sections of the track, acceleration, braking, and turning, well, that's where this truck shines. Now you guys have probably noticed these aren't my work boots. They're thin-soled driving shoes, and they allow better pedal feel and feedback, letting you feel more in control of what you're doing. Now so far, we're feeling pretty confident about our little pickup truck. Our Supercharged V8 is running great and making lots of power. The suspension feels tight and predictable, and if this darn rain will hold off a little bit, maybe we can go a little bit faster.
Now, what you may not realize is that Rolling Thunder, essentially, well, it's a Mustang. Same supercharged 4.6, same 6-speed transmission, about the same gears, big brakes, lots of safety gear, adjustable shocks, all that kind of stuff. But it was the only way we were going to ever get to build a Mustang on trucks, so don't tell the producers. Fairground Speedway Nashville is an 18-degree banked paved oval that's 0.6 of a mile long. And races have been run in this location since 1904. And it comes as no surprise that some of the best drivers in the world have run this track.
Patty sent Kyle here. Bobby Allison sent Davey here. He sent Clifford here. They sent Adam here, Adam Patty here. Dale Earnhardt Sr. sent Dale Jr. here. He said, go to Nashville. If you can win there, you can win anywhere. Everybody loves this racetrack.
Another guy who loves this track is Sterling Marlin, son of Cuckoo Marlin, the track's first back-to-back champion in '65 and '66. Now Sterling's a 2-time champ of the Daytona 500, a seasoned NASCAR vet, and it was cool to have him check out our truck.
Golly, what a motor.
Yeah, we shoehorned
How
a lot
in
in
the world
there.
did y'all get that thing in there?
And Sterling seemed to genuinely like what we have done.
I've been coming here since I was probably 2 months old. You know, Cale Yarborough and Bobby Allison, Richard Petty, and all of them watched them come off the corner here. And as a kid, you know, and it's pretty neat. To me, it's the best short track in the country. I mean, in the United States, it's the second oldest racetrack. A lot of history here. A lot of Cup champions have started here and won on the Cup and won races. So a lot of Daytona 500 champions. I think I counted one is 30-something guys who won the Daytona 500 have raced here. So it's a neat racetrack.
Now, we had a feeling the rain wasn't going to hold off forever, but the American Streetcar Series Run to Music City 2 is a rain or shine event. And sponsored by Jet Hot Coatings is the driving school that they put on the Friday before the weekend's events really get underway. Our good buddy Brian Finch and Kyle Tucker from Detroit Speed and Engineering put on the day-long school that ranges from classroom to in-car instruction. And the cool thing is you don't need a race car. You can use your daily driver because this class is about education.
That's what's so great about autocross. You don't have to have any experience and you don't have to have a high zoot car. You can bring out any car you want and run in an autocross.
And rain or shine, these guys were ready to run. And it was really cool seeing so many high-powered and great-looking cars and trucks not afraid of a few raindrops and willing to attack a wet and slick autocross course. So with the all clear from Kevin, I wiped the fog off the windshield, put the wipers on full bore, and gave it a shot. And you know what? The truck did surprisingly well. Usually with this much horsepower and rear tires this wide, it's typically a recipe for wagging the tail. But the truck was pretty much planted to the pavement. The tires did a great job of pushing the water out of the way and staying in contact with the asphalt, even through standing water. And major kudos to the guys in the yellow raincoats, willing to stand out here in the monsoon and work the course.
Hey, welcome back to Trucks, and welcome back to Fairground Speedway Nashville. We just had to come back on a dry day because it wasn't fair to you guys, and it was not fair to Rolling Thunder not to see the awesome potential of this great little street truck.
It's been a long time coming. You ready? Let's go.
Now, it was great having the Ranger here at a dry racetrack. because the last time we were here, so was Noah's Ark. And we've also made some suspension alignment changes as well. I always overcook that one. Over rotation. Now those changes we made were increased negative camber on the front tires, which clearly didn't do anything for rear grip. I thought we had a dry track. What happened?
Leftover water.
Now that increased negative camber will help even out front tire temperatures and even out the tire wear, which is a good thing since they're not exactly cheap. Now this truck's got a ton of adjustability built into it. Between alignment and our triple adjustable coilovers, we can set this thing up for just about any road course. But that's what it's made for. So we won't be trying to dial it in for a banked oval.
Flat spot what?
Maybe I should have given the rear a little more grip too.
Man, this thing makes so much power. Torque in the bottom end all the way up to the red line. This thing just pulls strong.
Now, a big reason this truck handles so well out of the box is because a lot of time was spent on both suspension software and in the shop making sure that the suspension was done correctly. And playing a big part of that is Jack Hidley from Maximum Motorsports. He made sure we had the right spring rates and the shocks were valved to match. The proof is in the video, so thanks, Jack. Now, the only concern we had all day was that after a handful of hot laps, the engine got a little bit warm and took some cool down time. But other than that, the truck performed flawlessly. Now, our extended length shifter that we got from American Powertrain made shifting our Magnum T56 6-speed both precise and smooth.
Man, this track's kind of got a rough texture, and it's kind of a fine line in between grip and losing control and spinning out.
Now, this low-angle shot is in real time and gives a great perspective on how fast this truck is getting around the racetrack. Now, the track surface is rough, and putting power down after a 180 transition onto pit lane is an exercise in throttle control. Now, our BFGs are street tires, and they're doing a great job of keeping our truck planted on the track. Now, it's probably a good idea that we installed brake cooling ducts, because we were working them hard. The truck was going from wide open throttle to a foot full of brake pedal. The truck didn't have much time to cool the brakes off, cruising around the oval.
Man, this thing pulls, it just never stops. Well, I hate to relinquish the driver's seat, but I guess it's only fair to give you a shot.
Now, this truck was years in the making, but after today, it's very clear to me, it's all worth it.
Ready to switch up?
Yep.
Not ready to give it up.
I won't bend it.
Just try to be nice and smooth on the transition from like fourth down into third or second up into third, just because the less you upset the truck, the better balance and more traction you're gonna have.
So far, this truck handles better than my Pro Touring Mustang.
Brake, 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 brake.
Now, I learned how to drive on a frozen lake in Canada, but it's a far cry from a high-banked oval, and Ryan was giving me some pointers that really helped. Competition driving is not just about going fast in a straight line. You got to pay attention to the sound of the tires and the feedback that the vehicle's giving you.
Turn in, it's gonna want it, it's gonna rotate, just let it. Yep. Yep, left, left. Braking, braking. Yep. Now just let feel it out. Yeah. Yep, third gear.
The combination of all of that raw power and a dry track can give you a false sense of confidence, but you've got to learn the balance and respect the track surface and its flaws to really get a good feel for driving at speed.
Running a little warm, running a little warm. All right, we got this thing running hot. We're gonna give it some cool down time,
It'll give us a chance to go over the line a little bit and figure things out. Next time he comes back out, we can hit a little bit harder. That was good, though.
We also wanted to give a big shout out to Robert and JP for volunteering their time to keep us safe here today on the track. And these guys are just one more reason to where Fairground Speedway is a great place to come and race, as well as have some good seat time in the stands. Thanks, guys.
All right, I'm strapped in. I'm ready. We good? All right, let's do it.
All right, which one's the brake?
Oh, man, I'm getting out.
Now, with a couple laps under my belt and the truck at normal operating temperature, it was time to kick it up a notch and stamp down on the loud pedal just a little bit harder. And trust me when I tell you that Rolling Thunder answers the call.
Get into third when you get a chance. Braking, turn in. Yep, turn in, get closer to the right side. Okay. There you go. Now just leave it there.
Now there's a lot going on and it is happening fast between what the truck and the track are telling you, plus somebody beside you feeding you real-time information and suggestions. Now it's a lot to absorb, but it's seat time, and that's the best teacher of all.
It's gonna rotate, just let it. Yep. Yep, left. Braking. Yep. Now just feel it out. Yeah.
Now the seat time is great, but actually getting to drive on the same track as Richard Petty, Dale Earnhardt, Bobby Allison, well, that's truly an honor. And that's something we get to tick off the bucket list. Not a bad day at work.
Man, I just don't want to stop. I want to keep going around in circles. I'd like to turn right sometime, but this is awesome.
Now Ryan's got his track license, he's had hours and hours of training, and I tell you what, it's sure nice to have somebody that can coach you through picking your line, when to brake, when to heel toe. So anytime you can take advantage of the Jet Hot Coating Schools, the American Streetcar Series, that type of thing, educate yourself. It sure is nice, and I sure appreciate it, man. Where is he? Cole.